FPGA program. So I am Rugendra Vasmaskar. I am conducting this session. So today we will be having 3 sessions. First session will be our FPGA designing and architecture and design flow session. Then there will be 2 programming sessions. So before starting the session, I would like to introduce you our HOD, Dr. Chandan Singh Rawat, and our IIC chairman, Dr. Nadir Charnia, and our deputy HOD, Mrs. Manisha Chattopadhyay, madam. Thank you, sir, for joining our session. So, Rawat, sir, please.
Yes.
Tell us a few words.
Thanks, Mugendra. Hello, everyone. Good morning. VLSI is a very popular emerging field in India today. Recently, Government of India declared a semiconductor policy. This was on 1st of January 2022. The aim of semiconductor policy was to create human resources that are required to grab the opportunities available in the VLSI field worldwide. This workshop gives the participants opportunity to understand the basic of VLSI design. The focus of this workshop is to train the faculties and students all around Mumbai University in Verilog programming and FPGA design. The mini project 2B in Electronics and Telecommunication branch is a compulsory subject for 3rd year. This workshop will help the teachers and students to successfully complete the mini project, which is compulsorily based upon FPGA in this course. I welcome all the participants on behalf of VES Institute of Technology. Hope you will have a very nice experience during this course. Thank you.
Sir, you are on mute, Mugendra.
Yes. Thank you, sir.
So add one or two lines also.
Yes, sir.
Dear participants, this Mugendra Vatmaskar, our faculty is very expert in this domain of VLSI and FPGA. So I just appeal you all to take the advantage of his expertise in this domain of VLSI and DSP and FPGA. This will be helpful in your mini project and not only in mini project but also in final year projects. Also, when we are going for commercialization of the product for at a semiconductor level, this prototyping will be helpful for commercialization of the product. And that's all I wanted to just convey my message for taking the advantage of this program. Please do it diligently. Thank you very much.
Thank you, sir. So we will start our session. So my first session will be on first we will go through what is FPGA, because many people starting with the FPGA are not knowing even what is the FPGA, what is tool, how this tool works. So all these things we will talk first. So the students who are not knowing about FPGA, they will also understand. Now many students are joining from stream. So we have nearly 320 registrations, including faculty and students for this workshop. So many will be joining on the YouTube stream. This session will be all only the introductory session for FPGA design flow, ISE flow, and from 12:45 I will start the actual programming. So before that you have to install the Xilinx Webpack version. So finish installing the Xilinx Webpack version. The link for the version is already shared onto the website. So download it and install it. So you can start the session of programming from 12:45. Okay, then I will start the presentation. Okay. Is my screen visible?
Yes, sir.
Yeah. Okay. Then we'll start with the first part, that is FPGA and programmable devices. In this session, I will cover first architecture of FPGA. Then I will cover up the ISC design flow. Then we will finish the session. So I will try to keep it as short as possible. Okay. So basically, objective of this session is to introduce the digital programmable devices like CPLDs, FPGA, then different programming technologies, coarse versus fine grain architectures, and some field programmable gate arrays. So you all are aware of these kind of logics. The previous old logics are like this: AND gates, OR gate. We will be having dual in packages. So basically, these kind of ICs are there. So 70 is a few gates in a single package, still available. We use these kind of ICs in our labs. Now, there are some ICs like this. These are for registers. The previous were the combinational logics. Now these are the sequential logics which are available. The flip-flops. Now comes after these innovations came the integrated circuits. The integrated circuit came in existence around 1962. When the first integrated circuit was made in the USA, that is Jack Kilby, who invented the first integrated circuit. And from that, the evolution happened. So now we are going to study few of those. So we are mostly interested in this part, FPGA, field programmable gate arrays. So our aim is for the FPGAs, but I will show you what are the, here only I have shown the categories. So ASIC, there will be 4 categories: gate arrays, cell-based ICs, structured ICs, and a full custom ICs. So here you can fully customize the IC according to the requirement. Everything is customizable. Everything can be changed. And basically, you can create an ASIC for... Hello? Okay. Okay, sorry, there was some problem with the streaming. I made someone co-host, and because of that, stream was stopping. So now the stream will not stop. So that's why I made some change. Sorry. Okay. So basically, the devices are ASIC. So here ASICs will be gate arrays, cell-based ICs, structured ICs, and full custom ICs. So all the ICs are manufactured as ASICs. So most of the ICs nowadays you see, those are all ASICs. So the ICs you see in the computers and for some specific applications, so all those are the ASICs. So the scope of this FPGA, this workshop is not for the ASIC. So we will only talk about the latter part. So there are other category called as a logic functions. So for logic functions, there are 2 types: programmable logic devices and the standard logic. In the programmable logic devices, there are 3 types: SPLDs, PALs, programmable array logics, CPLDs, then FPGAs. So we will mainly focus on FPGAs, but we'll go through these 2 also, SPLDs and CPLDs, which we already know. So what are programmable logic devices? So these are specialized integrated circuits consisting of an array of logic cells that can be interconnected by programming to realize different digital designs. So these are completely programmable, and it is having some array logics or cell structures which can be reprogrammed again and again, and accordingly the logic can be formulated. So all these internal connections or interconnections are electrically programmable. These are like switches which you can make on and off, and you will be able to program that connection. So there are the largest devices are now 4 million gets. Now this 4 million is also very less. Now there are very big FPGAs are available. Ultra scale plus Xilinx FPGAs are in the market, and you can do even a machine learning operations using these devices. For the understanding purpose, as most of the people joining here are newly understanding or just very much new to this technology, I kept it very simple and very basic for the FPGA understanding. So I kept only the basic understandable logic in this PPT. So the higher technologies and the larger devices, we will talk about it in the later part of the workshop. So the programmable logic devices. The first one is the programmable logic devices. So basically these programmable logic devices are made up of logic gates and programmable switches. There are inputs which are basically logic variables which create some logic, and the output which actually creates a logic function. So we can use these logic variables. We can program these logic gates and switches, and we will be able to make some logic function. So that is what called as a PLDs. So basically, we can have these acronyms. So SPLD, simple programmable logic device. PAL, programmable array of logic. CPLD, complex programmable logic device. PLD. FPGA, field programmable gate array. So we are interested in the field programmable gate array. So common resource. So in all these are the common resources. Memory lookup table, LUT. You might have heard this word many times, LUT. So this is the main part of all the FPGAs. The configuration and the capability of FPGA changes according to the lookup tables. So different FPGAs have different structures of lookup tables and different arrangement of lookup table. In this workshop, we are going to study Spartan 3A pneumato boards. So I have included the Spartan architecture, the basic architecture of the Spartan. You can find the Spartan 6 or a Vertex architecture from the datasheets. So it will be having AND or logic functions, simple gates, then input-output blocks, that is bidirectional latches, inverters, pull-up, pull-downs, and interconnect or routing, local, internal feedback, and global. Okay. So now CPLDs and FPGAs. So now look at this. This is the difference between the CPLD and FPGAs. So you can see the CPLD will look like a IC structure, while this is a sea of gates. You can see this. So this kind of structure is for the field programmable gate array. So architecture is PAL 22V10, like more combinational. Gate arrays like more register plus RAM. So it will be having a memory as well as registers as well as lookup tables. Then density, it will be having very low density, medium to high density for the FPGA. But now it is very high density nowadays for the FPGAs. Performance, predictable timing is up to 200 megahertz and application dependent up to 400 megahertz today. So interconnect, crossbar, and incremental. So these are the basic differences. You can understand from these differences that CPLDs are will be having a very low speed as well as the capability is also very low for the CPLDs. PLDs. So many of you have taught or studied some of products or SOP forms So these are implemented using the PLDs. So this is the AND plane. You can see this is the AND plane, and ORs are connected after that to create a function. So you can see A, B, C bar. So this is A, B, C bar. So this forms A, B, C bar. Then A bar, B, C. This is A bar, this is B, and this is C. This is ANDed, and these two ANDed together to create OR gate. So this OR operation will happen, and this is a F1. For F2, it will be like A bar, B bar, and ABC in the same way. So this is how the PLD structures is created. This is a combinatorial macro cell. So this is a CPLD architecture. So CPLD architecture contains this kind of PLDs. So AND OR arrays will be there, and each AND OR array will be connected. So there will be a PLD block which is consisting of this kind of arrays, and these blocks are connected with the IO blocks and interconnected wire. That completely forms the CPLD. That is how we get the CPLD. In practice, there will be more product terms. So that means these terms will be more. Then more routing resources, more macro cells, greater connectivity between the macro cells allow implementation of wider, more complex functions. So this is all is a CPLD. Now general structure of PLA. Now we'll go to the some other part, that is the FPGAs and PL. So PLA. So PLA will be consisting of like this: input buffers and inverters. There will be input buffers and inverters. Then there is the AND plane. So these will be the inputs basically, which will be coming from the buffers and inverters. You can see here. So these are the inverters, and before that buffers are connected to improve the strength, and then the AND plane will be there, and then there is a OR plane. Here the thing is that this AND plane is completely programmable, and OR plane is a programming plane. So this is a programmable logic, and this is the logic you want to implement. So look at this. This kind of structure is this. This is the AND plane, this is the programmable, and this is the OR plane. You can see this. So this is called PLA. So AND plane and OR plane. So two connections are made. So you can see X1, X2. So here it is making X1, X2. So P1 will be formed, then P2, P3, and P4 in the same way. So F1 will create a function P1 plus P2 plus P3. That means P1 or P2 or P3. And F2 will create P1 or P3 or P4. So this plane is also programmable. So you can select output whichever you want from the AND plane. Okay. So this is called the PLA schematic. Now the PAL. In PAL, the AND plane is programmable, but OR plane is fixed. Here OR plane is fixed. There is no programming available. Here you can see the programming is available for the OR plane. The same kind of programming is not available in the PAL. So OR plane is fixed. Here F1 is directly P1 and P1 or P2, and this is F2 is P3 or P4. So this is simple PAL. So now we will come to the PLD. So these can implement a combinational or a sequential logic. So you can see this kind of combinational or sequential logics are implemented, and it is connected with, now the same kind of planes are there. You can see this is the AND plane, this is the OR plane, but after that you can see some logic is added. This logic is nothing but a flip-flop, mux, and this kind of combinatorial and a sequential logic added together to create a macro cell, and such macro cells are used inside the FPGA. So what type of system is this? So before that, we'll talk about why CPLDs. So CPLDs are basically low-cost, mature development tools and products. So over 20 years of design experience, nowadays we use CPLDs, but now the use of FPGAs is very large, perfect for SOP and POS expression. Perfect for SOP and POS expression, coupled with 8-bit microprocessor. Okay. Okay, so these are perfect for the POS and SOP expressions, coupled with 8-bit microprocessor, powerful enough to control most appliances, and balanced connection and predictable timing. The problem with the CPLD is it can only implement simple logic functions. There is a lack of storage for the CPLDs. So that's why we wanted a better structure called as the FPGA. So this is the FPGA. So we will talk much more about this in this workshop throughout. And we will download our program onto this FPGA. So before downloading the program, you all have to understand what is the design flow, how to do a programming, what steps need to be followed to download onto the FPGA. Then and then only you will be able to download everything onto the FPGA. It is very easy. Most of the work is automated, but you have to follow the certain procedure, which is very much important in case of the these FPGAs. So now look at this. This is a symmetrical array. You can see this is a symmetrical array, and these are row based. This kind of row will be there. So these are called as a logic blocks, configurable logic blocks. And these are the interconnects. You can see these are the interconnects. So C of gates. So this is C of gates. Each will be consisting of slices. Slices will be completely consisting of lookup tables. Lookup tables will be made up of some gates. So that kind of structure will be there. So there will be logic blocks, PLD block, you can see, and the interconnect. So this is a hierarchical PLD. Okay. So we will go a little more inside the FPGA, then you will understand what exactly it is. So this is called as a island style of FPGA. Okay. So for island style of FPGAs, you can see this. There will be CLB. These are called as a configurable logic blocks. So these configurable logic blocks will be having some connections with input-output blocks. So FPGA consists of these kind of structures. There will be at the center configurable logic blocks. These are connected to IOBs through the interconnects. All these CLBs are also connected with each other using the CLBs, configurable logic blocks. So these are the programmable interconnects. You can see this. So everything, all these CLBs, IOBs are connected using the programmable interconnect. And this interconnect is also programmable. You can change the connection also from CLB to CLB or IOB to CLB. So that's why the FPGAs are very popular. Most of the time, FPGAs are used for creating the prototype or testing something. Nowadays, very popular. So this kind of structure is there basically. So there will be logic blocks, and then there is a switch matrix at the center, 4 switch matrix you can see. And these switch matrix are connected with multiple logic blocks you can see. And the connections can be programmable. These logic blocks inside also are programmable. So FPGA architecture in detail, you can see now. So this is, although I am showing a Xilinx Spartan 2E CLB, this is a basic slice, but most of the slice of the Spartan 3, Spartan 6 and Vertex also nearly similar. There is very little bit change, but if you go for the 7 series FPGAs, their slices and the CLB structures are completely different from this. So you can see here there is a lookup table. This is a CLB slice. Let me tell you, in the FPGA configuration block, there is a slice. There are two types of slice L and slice M. Slice M is with a memory like, and slice L is the lookup table. Okay, so basically each slice contains two lookup tables, one carry and control logic. See, generally in the 7 series FPGA, this carry and control logic is made up of carry look ahead adders, and then there will be flip-flops, okay, memory elements. So these kind of structure will be there. So here you can see there will be one lookup table, these two lookup tables, and then carry logic, and then there will be flip-flops. So this is the internal structure of the one CLB. So that means if you see in the device utilization, there is one slice used. That means two lookup tables used. There is a possibility that from the slice only one lookup table is used because your logic is not that large and it is using only one lookup table. So you will get to know the complete idea when you do the mapping onto the FPGA actually. So we will see later how does it differ and what are the actual effects onto the programming. So internally, the multiplexer you can see there will be internally multiplexer. So these multiplexers will be like this. So there are two types of output. See this. This is the slice and this is another slice. One slice will be having two lookup tables and another slice will be having two lookup tables. And this is a CLB, complete CLB, two slices, four lookup tables, and this is a multiplexer, two outputs. One first slice output goes from this and the second slice output goes from this. So you can use this output or you may use these two outputs also. Depending upon your logic, you can set it. Now the question is, are you going to program this? So no, you don't have to program actually this kind of logic. Internally programming, you just have to do a Verilog programming, and tool itself map the logic onto these lookup tables automatically. Until and unless you wanted to optimize the logic, you don't have to do the lookup table programming. There are techniques with which you can do the lookup table programming also. So if somebody is doing a research, then they have to do the lookup table kind of programming. Okay. So here it allows more effective routing. It helps implementing more functions, and it is helpful for selecting the RAMs. So is there any question up till now? So if anybody is having any question, please ask. I will answer that question. Then I will move to the next part. Because soon we are going to start the ISC design flow. So if you have any question, please ask. Okay. So we'll go to the next part. Okay. So this is called as a coarse grain structure. So more conventional FPGAs as coarse grain. You can see this kind of structure is there. Fewer more complex CLBs. So there will be CLBs which are very complex. And new FPGA have other built-in resources for high performance computing. So if you see the recent FPGAs, the recent FPGAs are the 7 series FPGAs or the ultra scale FPGAs. So these FPGAs are having a processor core inbuilt onto the FPGA, ARM Cortex processor core. So M9 core or M3, M4 cores are there. So you can get a ARM itself onto the FPGA. So recent FPGAs will be having one part which is of a processor, 25% part, and the remaining 75% you can put up your logic. So the 25% part which is dedicated to the processor is helpful connecting the interfaces, doing some programming. So because of that part, you will be able to do machine learning, image processing kind of coding very easily. So you can study all these things once you understand the basic flow and once you understand the basic FPGA design. So once you understand these things, other things are just scaling the logic and knowledge. Nothing much more difficult is there. So arithmetic supports. So FPGAs have built-in fast carry circuit, as I showing you all. So this is a built-in fast carry circuit. This fast carry circuit is nothing but a carry loop ahead adder circuitry. Then arithmetic performance is improved by using the dedicated carry logic. So if you see the recent 7 series FPGAs, they are having a 4-bit carry look ahead adder inside. So one CLB will be having 2 slices. One slice will be having 4 LUTs instead of 2 LUTs, which we have seen in the Spartan 3. And there will be a 4-bit carry look ahead logic in each slice, and you can use the F5 and F6 in the same way. So that kind of circuits will be there. The reason providing this carry look ahead adder logic circuitry is we use a 4-bit carry look ahead 4-bit adder where the carry ripples. So in this case, the carry will not ripple. And the carry will be very faster. So timing of the circuit, the speed of the circuit will improve. So dedicated multipliers are available in high capacity devices. So most of the Spartan 6, Vertex, 7 series FPGA, they will be having a 18 by 18 multipliers. So if you write A multiplied by B, so it will take a default device from the FPGA. So internally there are built-in multipliers. Those multipliers will be used. So why these are useful? These are very useful when you do the DSP kind of operations. So good arithmetic support is needed for DSP type of applications. So that support is also there. Basically, there will be chains, then buffers. So those kind of supports are also available. DSP 48 blocks are available in the higher level FPGAs. So internally, the structure will be like this. I already explained this structure. So these are the 4000 series structure. You can see 2 lookup tables, carry control logic, and then there will be flip-flops. So you can use it as now. What is the lookup table? We will see in the next slide how lookup table is used and why these are very popular. So this kind of structure is there. I have taken most of these figures from the Xilinx website, and this is all available in the data sheets of Xilinx also. So this is 4000 series of the Vertex. Now FPGA general structures. So you can see this is the internal general structure of the FPGA. On 4 sides there will be IO blocks. Internally there will be CLBs. Metrics, and these are the CLBs. So all these are connected together. So these CLBs, these are the CLBs, and all are the interconnects which can be used to connect everywhere. So look at this. FPGA basic SRAM logic. So this is a SRAM logic. A lookup table is there. With that there is a flip-flop and select control. So 1-bit information is stored here depending upon the logic implemented by the lookup table. So now what is lookup table? We are talking a lot about lookup table. So lookup table can be used to code any Boolean function of the inputs, unlike PLDs. So you can create any Boolean function using lookup tables, mainly used in SRAM based FPGAs to code combinational logic. What is SRAM based FPGAs and what is combinational logic, we'll see later. So this is lookup table G1, G2, G3, G4, and you will get output Z. So this is what happens. So look at this. Before programming, the lookup table will look like this. This is like a 2:1 multiplexers, which might have an input 0 or 1, and there will be a select line X1 and this select line X2. This select line decides which of the inputs get selected, and that output will come to the output. Okay, so now look at this. The simple function is implemented here. You can see both the 0 output is 1, both the 1 output is 1. So some kind of logic is implemented. I think this is a XNOR function because equality is happening here. So if both the zeros are, both inputs are same, output is 1, else output is 0. So XNOR function is implemented. So you can see 1, 0, 0, 1, and x1 and x2 will select accordingly. So instead of this kind of things will happen. So these inputs are used here, and depending upon the x1 and x2. So if you select 0, 0, what happens? See this. X1 is 0. So that means the top multiplexer will get selected. If x2 is 0, then the lower multiplexer is selected. So we are connecting selecting the first one. Okay. So x1 is 0. So that means we will talk about this only. Now x2 is 0. So x2 is 0. That means it is connected here. So this one will transfer here. Then it will transfer here. And f1 will be 1. Now, if x1 is 0, that means again the top multiplexer will get selected. X2 is 1. X2 is 1 means the 0 will get selected. So 0 will transfer to f1. Now 1, 0. In this case, what happens? X2 is 0. So x2 is 0. You can select 0. So this 0 will transfer this 0. So output will be 0 for this multiplexer. Now x2 is x1 is 1. So x1 is x1. That means this multiplexer will selected, and this 0 will get transferred to the f1. So this is how the circuit will be reprogrammed. So depending upon the input, you can reprogram the LUT again and again. So that's why lookup tables are very popular. So implementation of the combinational function using 4 input LUTs. Look at this. So you can implement 4 input LUT. So this is how you have to write a truth table, and this truth table will be mapped onto this lookup table. And accordingly, the functions will be selected, and accordingly, these lookup tables will be reconfigured. So this is the lookup table which we are very much interested in. So A, B, C, D, these all 4 inputs will be used, and according the logic will be selected. So programmable interconnects. Now the question is how these CLBs are getting connected with each other. So there are logic blocks, that is a configurable logic blocks, and these logic blocks will be connected to each other using this switching matrix. This switching matrix is like there are some techniques for selecting the CLBs and routing the structures. So we will not go much more in details of that. There are structures called H metrics, and they basically decide how to connect CLBs with each other. So there will be less delay and basically shortest time they wanted to utilize. So shortest path and shortest time. That is what the purpose is. So look at this. Before programming, the structure is like this. After programming, you can see this. So this is happened because of the switch matrix. So what is there inside the switch matrix? The switch matrix are like this. Internally, 6 pass transistors per switch matrix, interconnected point. So if you have learned basics of VLSI or taught VLSI, then you will understand what is switch pass transistor. So basically, these are the MOS transistors, and these are made on and off depending upon the gate voltage. So according to the voltage applied, the switch matrix basically decides which connection should be made. So this kind of connections will be there. So depending upon these values, so now here this is on, this transistor is on, this transistor is on. Then you can see here in this second case, this one, only this transistor is on and this transistor is on. All other are off. So here, this transistor is on. So that is how the connections will be there. All other transistors are off. So these are the switch matrix. So now there are 2 types of structure. coarse-grained, and the fine-grained FPGAs. Coarse-grained are the SRAM based. These are used by the Altera and Xilinx. There are multiple companies in the industry which manufacture or creates FPGA. Altera, Xilinx, Actel. Now, if I tell you, Altera is nothing but Intel. Intel bought Altera, take over the Altera. And Xilinx is nothing but AMD. So now from this name, you can understand how big these are. Altera is Intel, Xilinx is AMD. Okay. This happened last year because nowadays cloud computing is increasing, artificial intelligence is increasing. So these are making their integrated products. So that's why the FPGA industry is in boom now. So now there are another type of FPGA made by the Actel. If you want to find out the name of the company, then it is a Microsemi. There is a company called Microsemi. It is nothing but an Actel. So C of small logic blocks, predictable propagation delays, high performance timing, and one-time programmable. So these are the anti-fuse based active FPGAs, fine-grained architecture. So these are unpredictable propagation delays here, reprogrammable. ये again and again आप program कर सकते हो. Dedicated functions, fast carry, etc. Large complex logic blocks. So most of the market is taken by the Xilinx. Nearly 60-70% market is in control of Xilinx. The remaining market shared by the Altera and Actel. Actel basically deals much more in the defense sector. They have completely different tools and everything. Altera also needs a different tool called as Quartus. Xilinx have their own tool, ISE and Vivado. So depending upon the FPGAs, you need a different programming tool. So in this workshop, we will focus on the Xilinx tool and Xilinx FPGAs. Why Xilinx tool and FPGAs? So many colleges are already having the Xilinx tools and few FPGAs also. Maybe few colleges will be having Altera and Quartus tool. Xilinx tool is very much known to students. That's why we prefer Xilinx. But equally, these tools are also good. Okay. FPGA examples. So this is the Xilinx 4000 series. You can see this. So now CPLDs or FPGAs. We already saw what is CPLD on FPGA. So difference. CPLDs are non-volatile. FPGAs are volatile and made up of SRAM configuration. They need a JTAG setting. Here you can have nowadays USB setting and USB connections are there. Wide fan-in, fast counter, state machines, combinational logic, small student projects, lower level course. For that, you can use CPLD. But here you can have a computer architecture, processors, DSP processors that you can design using FPGA. It has an ASIC-like design flow. So you can test your ASIC design before going to ASIC design. You can test it onto the FPGA because similar kind of flow is there. Then PROM required for the non-volatile operation and fair size project implementation. So nowadays, very large size project implementation is also possible. Many machine learning, artificial intelligence algorithms are also implemented using the FPGAs. So now we'll come. So this is all about the FPGAs and CPLDs. So if anybody is having any question, please ask. I will wait for a minute and then I will start actual ISE design flow and then I will show you the ISE. So if you have any questions about the FPGAs and CPLDs, please ask. Otherwise, I will start with the design.
Sir?
Yeah. Yes,
sir, I have doubt about that switch matrix, sir.
Yes.
Sir, in switch matrix, sir, it is showing like four pass transistors. Sir, actually we have, so sir, we have like two things, like column and rows.
Yes.
So like, but when it is shown, so 4 points are connecting. So what is, we are connecting. Sir, I'm not understanding that connection.
Madam, basically these connections are now very much automated, and all
Hmm.
these will be given inputs depending upon the application you put. So those transistors will be made on and off. So in all these cases, these transistors are off. These are not connected. Only these transistors are on. So central lines are most of the time is off. Here only central lines are on. You can see all the transistors are on in this case.
Yes, sir.
Sorry, off. All the off.
Off. It is off. So means, sir, when the rows and columns has to be connected, so all the 4 transistors should be on. It's like that.
Yes. See this. In this case, column and row both are connected. This line.
Yes, sir. Correct.
This pass transistor is also on.
Okay. Yes.
So
Thank you.
fusing happens automatically. We don't have to do anything, but it is for the understanding purpose how the interconnects are connected inside.
And even sir, we came to know about the use of it. I mean, pass transistor one of the application.
Yeah.
Yes.
So many people actually do not understand how important are these MOSFETs and pass transistors.
Yes.
So in all the syllabus, pass transistors are there, MOSFETs are there, but people do not understand in the background what is happening. So you can see what's happening inside. Yes. So all these structures are made up of the transistors only internally.
Yes, sir. Thank you, sir.
Okay. Is there any other question? Okay, then we'll go to the next Xilinx design flow, ISC design flow. So this is called basically VLSI design flow. So now, what we do basically, so up till now we have understood what is FPGA. Now we wanted to write a program and put it onto the FPGA. So what is the procedure and what procedure we need to follow, what type of programming we need, and how to do all these things. So all these things are done through the tool called as a Xilinx, ISC. So for that tool, there is a specific procedure. So if I say this is a simple flow which you have to follow and do the configuration on the device, then you will understand what exactly happens when you develop a project onto the FPGA. So see this. First, you have to give a specification. The specification, depending upon the specification, HDL or a schematic is created. So Xilinx tool takes HDL, that is a VHDL or a Verilog program, or a schematic, that is a kind of a netlist, and that can be given to the tool. So HDL will be like explaining the behavior or a functionality of your application. So if you are saying, I wanted to develop AND gate, then define AND gate, functionality of AND gate. How you can define the functionality of AND gate? You can define functionality using a truth table, or you can define the functionality using the equation. We are knowing the equation A and B, or you can behaviorally tell if all the inputs are 1, output is 0. Otherwise, output all the inputs are 1, output is 1. Otherwise, output is 0. So that is the behavioral functionality. So one of these methods can be used in the HDL to explain the functionality. So that is what we do. And schematics, these can be given from the different tools. Netlist can be given. So somebody has their own programs already made and they don't want to share the programs. They do these kind of things. Advanced procedures are there. Right now, we are only focusing on the HDL. Then after the specification, HDL will be created. VHDL, Verilog program will be created. That is synthesized. Synthesis means creating a netlist. So we create a generic netlist. Netlist means how the lookup tables. We have seen the FPGAs. So when you write a program, these programs map all the inputs and outputs to the lookup tables. Lookup tables create the AND gate, and the internal connections are made. That is called as a generic netlist. So that generic netlist will be mapped to the technology. So whatever FPGA you create, depending upon that, it will be mapped to the FPGA. Remember, this generic netlist is device dependent. So one device netlist will not work for the another device netlist. So if you change the name of the FPGA, you have to go through this process again, because this connection will change. So all FPGAs will be having a different connection. So you have to go for the process completely again. Okay. Then what happens when you finish the technology mapping? You have to put that information onto the FPGA and place and route, and then create a bit stream which will be downloaded onto the FPGA. Now the question is, do you have to do all these things manually? If you have to do this thing manually, very difficult. You have to do synthesis, then create a technology mapping, place and route. Then for your understanding, and a good news is that you don't have to do anything. You just have to write a VHDL program and download it onto the FPGA. These all things are done by the tool automatically, but you have to follow the process and it will take time. Okay. So this is a Xilinx design flow. So you can see there is a schematics capture or HDL, which creates a netlist, NGD build, and we can map it onto the for the floor planning. That means place and route we can arrange. So there is these tools allow you can arrange internal lookup tables, or you can do the floor planning according to your requirement. If you feel the tool is not doing a good work, you can arrange these things on yourself manually. So that is also possible. Then design MPF will be created, and the final place and route will be done, and design NCD will be created, which will be downloaded onto the FPGA. So what do you mean by the place and route? So placement, what does it mean? So look at this. So this is a simple picture which will explain what exactly the tool do inside. This is a complete automated process. You don't have to worry about it. The placement software chooses which one of the thousands of the logic blocks within an FPGA will implement the circuit. So look at this. So internally, when you write a program, the circuit netlist will be like this. This red will be connected to green. This yellow will be connected to these two. Now here, when it does at the starting point, this will not take care how much time it is taking, the first synthesis part. So when synthesis is done, this kind of netlist will be created, this netlist. But this netlist will take a more time. But the goal of this strategy is to minimize the amount of routing required to make all necessary connection between the logic blocks and maximize the circuit speed. To maximize the circuit speed, you have to make arrangement in such a way that wire delays will be less, and the blocks will be placed in such a way that it will reduce the wire delays and increase the speed. Okay, so look at this. So this blue block is brought here, this yellow block is brought here, because this yellow block is connected to this block and red block. So these two will be there, and this red block is connected to other blocks. So simple placement will change the thing. So look at this. So now you can see the new placement. So this part is called as a placement. So all these CLBs are replaced and the routing happens. So routing will be like this. It is the new routing. The routing software automatically determines which switches should be on and which should be off. As we have just discussed before some time, that switch matrix. So that switch matrix now comes into the picture and decides which are connected together. So look at this. This is a placement. So all these wire connections. So previously also these wire connections are controlled by the switch matrix. The same connection is controlled by the placement and routing software. Okay. So after routing, you can see now the delay is very less. So shorter connections means faster circuitry. The goal in this stage is to minimize the length of the connection and the number of switches required to route the signal. So that is called routing. So now, this is a complete design cycle, you can see. So is there any question related to the placement and routing? If anybody is having any question, please ask. I can explain what is placement and routing. It is very simple. Okay, so we will move ahead. Okay, now look at the design cycle. So the complete design cycle you can see here. There are two entry methods, visual, that is schematic, and VHDL or a Verilog programming. This is called electronic design automation. You can put this to the EDA tools. There are multiple EDA tools which are available. So you can give it as a schematic, you can give it as a text, then you can translate and merge. That means you can program. So state machine, block diagram, table, whatever you wanted to give, you can give it as a visual, or you can program it. So generally what visual tool is, so if anybody is not knowing how to do a VHDL Verilog programming, they can also use these tools. The only thing is that they have to go to the schematic way. So that means few of you must have used MATLAB. So in MATLAB Simulink, you can create structures, arrays, architectures. So you can create pull blocks, make a simulation, and use a HDL coder toolbox. And that coder toolbox will create a VHDL code, and which you can synthesize, simulate, and download onto the FPGA. There are some companies which gives the complete integrated solution, like National Instruments. They give a complete integrated solution using LabVIEW. So on LabVIEW, you can create pull blocks, make a simulation, functional simulation, which will be converted to the HDL code and downloaded onto the FPGA directly by using the binary files. So you don't have to go through the programming. So if you are not knowing programming, you can use alternative solutions. So multiple alternative solutions are available. For Xilinx, there is called as a Xilinx system generator. The system generator uses a MATLAB Simulink for doing all these kind of things. So you can understand how these tools are also interconnected. MATLAB, Xilinx, these tools are interconnected and they use each other's resources. So entry method. Schematics only for small and easy designs. VHDL for all designs, portable. So the same thing is for the Verilog. So you can see this. This is for the entry method. This is for the simulation. So for simulation, translate and merge, you can do the functional simulation, then do optimization and mapping. As I shown you the placement and routing, then we can do the final simulation on the board. Create a, before going to the board, we can create a simulation. If there is a mistake, we can go back and redo the things. So if you find mistake on any level, if you find mistake on the simulation after the synthesis, this is translate and merge means when you actually convert into the netlist. You can do one simulation here, and if you can check the first functionality and the next functionality is same, then you can move to the optimization, mapping, place and routing, and again do the simulation. If that is correct, then you can create a configuration file bit per line and download it onto the board. If the first simulation doesn't match, so that means your code is wrong, or whatever perception or the specification you have taken, or whatever logic you have designed is wrong. You have to redesign the logic and again do the translate and merge. Translate and merge means synthesize XST, again synthesize the design. So simulate independent of the FPGA type, may postpone selection, no detailed timing. Simulation after placement and routing is a detailed timing. So this will actually tell you how much timing required on the board. The first will tell you the information about the how much timing can be possible, but this is not the exact time, because it is not actually the mapped timing, it is a netlist time. So this time will be improved in this case. So design verification. Designs can be verified with integral simulator debugger. So we have simulators for Xilinx, there is a ISE simulator through which we can write a test bench. Test bench is a code which is written for giving stimulus or inputs to your code, whatever code you wanted to write. Like if you write a full adder, if you want to give a stimulus, apply input to that. So you have to write a test bench. So that is called as a stimulus or a test bench for the design, and you can test that design using this. So for that, you need a simulator. In market, there are multiple simulators: ISE simulator, Model Sim simulator, Questa Sim simulator, then Quartus simulator. Many simulators are available. iCaros is a free tool available. GHDL is for VHDL. So multiple simulation tools are also available which may use. Simulation possible on single units or any hierarchical grouping up to entire design tree. Simulation results can be viewed graphically or textually. So you can see waveform as well as you can download it onto the text file and check that text file using programming. So simulation results can be used in a tandem with the debugger to assist analysis. So there are debuggers also which we can find out where is the mistake. You can apply breakpoints. So all these things are possible. Whatever you can do in C++, the same kind of things you can do in the VHDL and Verilog also. So this is a complete designing cycle for the Verilog. You can see the same cycle. There are tools called Cadence also available. Xilinx, Cadence, multiple tools are there. So this is a complete design flow for the Xilinx. So now we will finish. I have taken this diagram from Xilinx. So you can see I have taken from their data sheets directly. So first, plan and budget, whatever your project, plan and budget, create code and schematic, then create a HDL RTL simulation, synthesize it, create a functional simulation. So this HDL and functional simulation should be matched. If it is not matching, then you have to go back and create your code again. If there is a mistake in code, you can modify the code. If there is a mistake in a plan, then you have to modify the plan. So you have to do it again do the HDL simulation, synthesize it. If it is successful, if these two are matching, then you have to go for the implement. Implement has following step: translate, map, place and route. After each step, there will be a simulation possible. We generally do simulation after the place and route. That place and route simulation or a map simulation will be matched with the again functional simulation. If these two are matching, then we have to go for the timing closure. So timing simulation is also done. If this is also matching, this is generally happens in the picoseconds, and these are in the nanoseconds. These are very slow simulations. But once you create a bit file, you can download it onto the FPGA using tools. There are external tools. Also, Xilinx has their own tool for downloading onto the FPGA called as an impact that you can use. And after downloading it, you can check it onto the board. That's it. So this is a complete Xilinx design flow. So how logic optimization happens, you can see. With some clever thinking, code can be optimized to work faster or use less gates. The tools to do this for use. So look at this: AC plus AD plus BC plus DB. You can see this. So G is equal to ABC. So this G can be utilized in this. So F can be made available like this: C plus G, A plus B. So this E can be used here also. So this will reduce the number of gates. Okay. Simple. This is a Boolean algebra. You can understand very easily. So this is a 3 input lookup tables. So these are the market vendors available. So this is last slide. So Actel, Xilinx, Altera, EPLD, LCA, then Xilinx CPLD. So these are the differences between this. You can say Actel is polydiffusion anti-fuse. I already told. All these are the SRAM based technologies. This is EEPROM or EEPROM based technologies. Size of programming elements small but requires contacts to matter. 2 inverters, pass and switch devices, logic. The same kind of things are there in most of the things. So you can do programming using any one of these devices. Right now we are going to use Xilinx. So that's it for the presentation. If anybody is having any question related to this, please tell me. Otherwise, I will start Xilinx. So first, I will show you how to use Xilinx. So in first part only, I will show you what is Xilinx, what are the parts, which is the project area, which is the programming area, and then we'll go to the programming after the first session. So 12:45, we will restart the session, and right now I will start IS. So is there anybody is having any question? So Verilog programming, today I will not directly teach Verilog programming because you will get bored if I start only theoretical part. The better way, we will learn Verilog using hands-on directly. Is that okay with everyone? So you all can able to do directly programming. I will show all the techniques required for programming. So I hope everyone has downloaded the Xilinx. Everybody is having the Xilinx webpack. So if you are having the Numato boards, that is also good. Okay. So shall we start the ISE? If anybody is having any question, please ask. So are you able to see the site I'm showing? Is it visible? Please tell me.
Yes, sir.
So many students, teachers are asking me which board we should use. So you can use this board. These are very cheap boards, $47. So you can directly order this from the Numato lab or numato.com. From there, you will be able to order this board. Today, we are going to use this board. In this, there is one more board. I will show you another board. Multiple boards are available. Right now, for today's lecture, this workshop, I'm choosing this Albert V2. I'm having many codes for the Papilio boards also. Later, I will, in next month, I will share some things on Zinc also. So that is also possible with regard to ISE. But this workshop is a completely fundamental, basic understanding how to do coding. Then you can try more and more things on yourself or on your own. Okay. So look at this. This is a board. So this board is a Spartan 3A FPGA. It is having Spartan 3A FPGA. As we are having mini project, for mini project it is enough. For bigger project, this board is not enough. But for mini project, for basic understanding and starting with the programming, this board is more than enough. You can see it will be having 3 7-segment displays. Multiple extensions are available, 4 extensions. You can see the 8 LEDs, switches. Okay. Then there are these push buttons. Those are also available. VGA. You can see audio jack, SD RAM card. Some extensions are also available, and you can connect power here. USB connectivity also you can give. So many things are available already onto this board directly. Okay. So today we are going to use LEDs and 7-segment display. So in the next 2 sessions, I will tell you how to use LEDs, push buttons, switches, and how to use the 7-segment display. So today's session will end with using 7-segment these LEDs and these parts. So in this workshop, we are not going to work on the VGA and all these things, but I will tell you what are the alternatives for it, because it is not possible to cover everything in 18 hours. These are very big things, and if I go with this kind of program, it will be very difficult to cope up also. From the next week, I will focus more on the programming, Verilog programming, how to do a Verilog programming, and how to understand the logic. Okay, so this FPGA is having this kind of capabilities: flash memory of 16 MB, and VG output is there. Micro SD cards are possible, as I shown all these things. So the features of these FPGAs are like this. You can see. So power jack you can connect here. Power LED is there. So 7-segment displays, as Aka said. This is a JTAG header, GPIO header. So DIP switches. You can connect externally also GPIOs. These are the 4 GPIO headers. So if you wanted to connect more wires and put it onto the those breadboards, that is also possible. Connect wire and use breadboard for 7-segment LCD display or anything. You just have to program basic things. So all the tutorials are also available on this website. So everything is available. So we are using Albert V2 boards. There is one more board available called as a MIMAS. Okay, this is a Spartan 6 board. It is a little bit bigger than the previous board. So if you are planning to buy something into the college, then buy these boards. You may buy Albert V2. Albert V2 in the range of, we bought it at the range of 4,500. And MIMAS we bought at 5,400 around. So I'm having few proposals. Quotations. I will send it to all whoever wants it. Okay. So this is the older version of the MIMAS. Newer version of the MIMAS is not. It is somewhat different. This is not the MIMAS I'm looking for. MIMAS. So newer MIMAS is also available. Okay. This is a newer version of the MIMAS. No, but this is Arctic 7 FPGA. Yeah, this is Spartan 6 board, which I'm looking for. MIMAS V2. So you can see here DDR is also available. DDR SDRAM. So it is a little bit costlier than the previous one. Same kind of LEDs, push buttons, switches, everything is there. Addition is the DDR SDRAM. Okay. So, and the capability is more. Spartan 6 FPGAs. It will be having more number of lookup tables compared to the previous one. So I'm having both the boards. Later I will show you few more boards. So right now I will start showing you the ISE. So I will stop the presentation. If anybody is having any question, I will answer. Otherwise, we will start the presentation directly. So shall I start the presentation?
Yes. Hello, sir. One doubt I have. Like for all the suggested list mentioned in the syllabus, is Albert V2 is enough to buy it?
Yes, yes. Sir, on this you can go up to nearly 8-bit, 16-bit multipliers also. Easy.
Okay, sir. Okay. Thank you, sir.
Most of us are doing projects which are under 1,000 lookup tables or 5,000 lookup tables. Hardly 4,000, 5,000 lookup tables. So if that is not fitting, what I suggest is in our college, we have got 26 Albert V2, 25 Albert V2 and 5 MIMAS. And we are also having Spartan 6 FPGAs of Papilio Pro, and we are having higher FPGAs also. But if you are buying in your college, you may buy few Albert V2 and few MIMAS. Few colleges already informed me they are having Arctics and basis FPGAs also. Those are also very good. So for all these FPGA, the procedure is same. Where the changes, I will tell during the workshop. कि exactly change कहाँ होता है, वो change मैं आपको exactly बता देता हूँ. Right now, I will only introduce the tool. Okay?
Okay, sir. Thank you, sir.
So I hope everyone has installed the tool. If you have not installed the tool, I will show you the site from where you can download. Now we are having a 1 hour time. So during that time you can download. So you can see this from this website, Xilinx download. you may go here and see for ISE archive, where you can find ISE downloads. So you have to take this 14.7 Windows 10 version, download it, and when you start installing, I will tell you select Webpack. ये जल्दी डाउनलोड हो जाएगा, इंस्टॉल हो जाएगा. ये डाउनलोड होने के बाद इंस्टॉल होने में भी टाइम लेता है, तो इंस्टॉल करने के लिए ओनली वेबपैक डाउनलोड कर लीजिए. ओके,
वेबपैक कहाँ पे मिलेगा सर?
सर वही डाउनलोड करोगे ना, तो इंस्टॉल करते टाइम आपको ऑप्शन आएगा वेबपैक का.
ओके,
वो पूछेगा कि ISE डिजाइन सूट डाउनलोड करना है या इंस्टॉल क्या करना है, वो पूछेगा बेसिकली. ISE डिजाइन सूट और ISE के मल्टीपल प्रोडक्ट्स है. So
Yes,
you
sir.
can select only Webpack, which will be very small.
Okay, sir. Thank
For
you.
this workshop,
Sir, I have one question. Can I interrupt, sir?
yes, please, ma'am.
Sir, I have on my laptop Windows 11 and I tried to install 14.7, but it is going up to 84%. And later on, it is getting stuck. It is not moving forward. Is there any remedy, sir, for Windows 11?
Madam, right now what I can tell you is problem कहाँ है हम लोग अभी बता नहीं सकते. Probably ना वो 84% तक गया है, इसका मतलब उसने कुछ तो पॉपअप किया होगा. Probably you are having some that virus software, protection software.
No, sir.
Firewall.
I have removed the antivirus also. And on the internet, now Google, I can see the many people are facing the same issues. Whatever message I was getting, error, same error it is shown on the Google also. Many people are facing. So few of our students have tried on virtual machine, but that will consume a lot of space and memory, and speed limitation is also coming.
मैडम अल्टरनेटिव आई कैन टेल यू इज उसको स्टॉप कीजिए. प्रॉबेबली आप पूरा DA इंस्टॉल कर रहे हो, तो ओनली वेबपैक इंस्टॉल करो. ओनली वेबपैक इंस्टॉल करो, वो जल्दी हो जाएगा इंस्टॉल. वो ज्यादा कुछ प्रॉब्लम क्रिएट नहीं करता है. तो ISE डिजाइन सूट पूरा इंस्टॉल ही मत करो. दैट्स इज व्हाट आई एम टेलिंग यू कि सबको मैं वही बता रहा हूँ, वेबपैक इंस्टॉल करो, जल्दी हो जाएगा.
Rugindra sir, will you repeat the process please for downloading?
Yes, please, I will show you, madam. Just a minute. मैं आपको एक डाउनलोड का ओपन करके भी दिखाता हूँ, दिखता कैसे है ये सब कुछ. Just a minute.
सर लिंक चॅट बॉक्स मध्ये टाकलं तर बरं होईल.
हो मी टाकतो सर. सर होतं काय माहिती का, मी ऑलरेडी त्या वेबसाईटवर पण लिंक टाकलेली आहे, पण हे ना डायरेक्टली त्या लिंकवर जात नाही, तिथे तुम्हाला शोधावंच लागतं ते.
ओके हां.
प्रॉब्लेम तो आहे, बाकी काही प्रॉब्लेम नाही. मी सो यू कॅन सी दिस. So here ISE archive, go to ISE archive. This is the link actually. I will put this link into the chat box. Okay, I have put down the second link आप use करो. So in ISE archive, click on the 14.7 Windows 10. Okay. So ये highest version available है. इसके lower versions को भी आप choose कर सकते हो अगर आपको बहुत ज़्यादा problem आ रहा है तो. That will also work, but the best solution is you may use the latest one. Okay.
Sir, one question. Sir,
yeah.
Sir, in my case, the installation process is going on. It's asking for the third-party agreement or the end user.
Accept, madam. There will not be any problem.
Both or anyone.
Accept, madam. Actually, उनके जो drivers हैं वो third party है. There will not be any problem. Don't.
So I can accept anything.
Yes, madam. It is a very safe tool. Don't worry.
Excuse me, sir. I have installed Vivado Archive 2019.2 version. So will it do, or do I need to install the 14 this?
Madam, that will also work. The only thing is that it is a advanced version. So I am not covering Vivado, although I know Vivado, but in fact I use Vivado for my all work. But I am using ISE for the purpose that everyone should understand. तो Vivado भी चलेगा. Vivado में जब आप डाउनलोड करोगे ना, तो ISE भी डाउनलोड होके आ जाता है.
Okay, so no need to install again, ना sir?
You have to check कि आपने क्या इंस्टॉल किया है. if there is a problem, what you can do is you can again restart the download, and it will ask whether multiple options. From that, select ISE and you will be able to download the ISE. I will show the process just a minute.
Okay, sir.
Better I will show. Yes. Yes. Actually, there is no need to install through the open VirtualBox because I haven't installed through the VirtualBox. Directly, it also get installed. So I actually don't know what is the solution for that, because many people are saying this kind of problems happening, but I haven't faced any such problem. So I will look into it and I will send a solution soon about it. Right now, at least there is no need to do this kind of things. I will show exactly hota kya hai. I'm trying to show the same thing. Yeah. Any other question? Yes. I'm showing. That is what I'm doing. See, this is the version I have downloaded. Xilinx ISE DS Win 14.7 10151. By the way, I am having licensed version also with me. My college is also having licensed version, but I'm using this version, Windows version. I'm personally having Vivado license with me. So right now I'm using this. You can see, you just have to click on the setup. So is it visible to everyone? Please tell me.
Yes, sir.
Yeah. So now click on the yes. Once the setup is on, my version is Windows 10. So you can see if Windows 10 पे चल रहा है तो बाकी सब पे चलना ही चाहिए. मैंने in the morning I have installed it onto the Windows 7 also. That is also working fine. So if nothing is happening, I will try to share this. Okay. You can see this. There is a note to reduce the installation time. We recommend that you disable any antivirus software before continuing. So आपका कोई भी antivirus software है उसको बंद करो. So these are the steps. Now next. So you may accept all the terms and conditions. There will not be any problem. They give you the Webpack license. So accept it. You may read if you want. Okay. So now by default it installs ISE Design System Edition. You may click on ISE Webpack.
Excuse me, sir.
Yeah.
Sir, I am here at 14.7 download page, and it is showing that it is supported to Windows 7. Windows 8, it is is it working on workable on Windows 8?
Yes, sir. Windows 7 के ऊपर सब पे चलता है वो 14.7.
Windows 7, Windows मिस XP सर्वर बोलते उसके ऊपर सब पे चलेगा.
सर मैं अभी जो यूज कर रहा हूँ वो 14.7 ही है. Windows 10 है मेरे पास.
ओके वो विंडोज 4. क्या है 14.7 का विंडोज 10 का दिया ना, उसके नीचे जो है उसमें विंडोज 7 दिया है, मींस विंडोज 8 पे भी चलेगा वो.
हाँ चलेगा सर. मोस्टली तो ऊपर वाले वर्जन में चलना ही चाहिए.
ओके सर, थैंक यू.
ओके. सो ये सबको दिख रहा है ISE Webpack. You can select ISE Webpack. So disk space required आपको समझ में आ जाएगा यहाँ क्या है. अगर आप डिजाइन सूट चूज करते हो तो यहाँ देखो disk space बढ़ जाता है. So you can use this also, ISE design suit logic design, but we need basically Webpack. Webpack is more than enough. और ये half an hour लेता है installation. Just click on next and it will start installing. That's it. So installation option में भी आप देख सकते हो कि क्या क्या आपको चाहिए. केबल ड्राइवर्स वगैरह सब इंस्टॉल करने दो, कोई प्रॉब्लम नहीं है. Then select the destination directory if you want, and that's it. Start. So this is what you have to do. Nothing else. ये सब कर लेगा अपने आप.
Sir, I have a doubt, sir.
Yes.
Sir, during installation, there's an error pop-up saying that installation cannot be performed. Virtualization is not enabled in BIOS. What's that, sir?
Actually, sir, I haven't got that kind of error. I haven't actually got that error. I will let you know. ये सब बहुत सारे लोग मुझे पूछ रहे हैं कि ये virtualization का error आ रहा है.
Yes,
But
sir.
कुछ computers में आ रहा है, कुछ computers में नहीं आ रहा है. Especially Windows के कुछ versions में ये virtualization का error आ रहा है. क्यों आ रहा है? I actually don't know. Because whenever I install, I never got this error. What I can do is I can share this version with everybody. So you all be able to download this version and install.
Yes, sir. Can you share that setup file only directly so that we all can run, if it is possible?
Yes, sir. But आज तो होगा कि नहीं possible
I
नहीं है,
understand, I
पता नहीं,
understand.
क्योंकि it is very large file.
Yes.
But
yes,
I
yes.
will share. ये 6.1 17 GB का file है. See, I'm having a license also actually. So मैं share करता हूँ sir ये.
Sir, for time being, is there any online simulator which we can use for this session?
Sir, there are online simulator, but the problem is that those are different from this. The ISC Webpack is the basic you can use right now.
Okay, sir.
There are simulators, sir. I'm not saying कि वहाँ simulator नहीं है, बहुत सारे simulators हैं. And एक simulator है EDA Playground, where you can do the coding. At least sir आप coding कर सकते हैं. वो भी मैं दिखा देता हूँ एक्चुअली उसके बीच में. ओनली थिंग इज दैट आप बोर्ड पे डाउनलोडिंग का प्रोसीजर उस पे नहीं कर पाएंगे.
So for today's session, it will work, na?
Yes, sir. For today's session, sir, today's session is only Verilog programming basics. Today we are going to do only the basic designing और ये YouTube पे रहेगा. आज आपको सिर्फ प्रोसीजर सबको समझना है कि करना क्या क्या है. Next week will be very lengthy process. Because next week we are going to write bigger programs like Wallace multiplier kind of programs. So that takes time.
Murgendra sir,
Yes.
do you have Windows or Windows Pro, Windows 10 Pro on your PC? The students are asking. Maybe because of that you're not getting the error of virtualization.
Madam, I'm not having Pro, only Windows.
Okay, sir.
Yeah, probably that is the reason. So I will also go through that error. I'm also not knowing that because I never came across that error. Windows 7 के लिए भी मुझे कोई error नहीं आया. What I suggest is आप lower version एक आध install करके देखो. That might work.
Yes, sir. Even I didn't get any error, but our students are getting the error while installation.
Yeah,
I'm having 14.
Madam, few people are getting the error, few people are not getting
Yes.
the error. It is basically dependent upon the machine also.
Yes.
आज तक मुझे कभी कोई एरर नहीं आया, तो मुझे एक्चुअली पता नहीं है कि ऐसा कुछ एरर आता है.
So, what version you can suggest for downloading?
Sir, take any lower version. Sir, just a minute. I will suggest from the Xilinx website. So I will not start this session. We will just try to find out which better version you can take, and then I will start the session in next lecture only. Okay. We'll start next session and in that only. Sir, ये 14.7 जो है ना, multi-file download, ये भी आप use कर सकते हो. This session is also good. Sorry, here you can see Windows 7. ये maximum जगह पे चलना चाहिए Windows 7 वाला 14.7.
Does it work on XP also? Was it there? I think that's.
XP पे मैडम मोस्टली ना कोई वर्क नहीं करेगा. XP पे चलाना है तो आप यूज 9.2. 9.2 या 12 चलता है XP पे. एक्चुअली ये डाउनलोड हो जाता है, चल जाता है. मेरे पास विस्टा है, विस्टा पे भी चलता है मेरे यहाँ.
अच्छा.
सो बट मेरा जो है ना वो 11 पॉइंट के ऊपर चलता नहीं है. 14 तक चलता है XP पे, बट स्लो हो जाता है थोड़ा.
Yes. True.
मेरे दूसरे कंप्यूटर पे विस्टा है.
अच्छा.
सो वहाँ प्रोफेशनल वर्जन इंस्टॉल्ड है, बट वो उसको मैं अपडेट नहीं कर सकता. Okay, so you may use this version, another version, full product installation ISC design tool 14.7. ये वर्जन ले सकते हैं आप, ये भी चलेगा. मोस्टली सबके लिए ये चल सकता है. वंस आई इंस्टॉल दिस, ये दोनों का मिक्स वर्जन है.
Yes, sir, successfully it is installed.
Yeah.
Sir, which one? 14.3.
ये भी अच्छा है. 14.34 ये भी वर्जन इंस्टॉल कर सकते हैं आप. यू मे ट्राई दिस वर्जन.
सर मेरे पास, एक्सक्यूज मी सर.
हाँ
सर मेरे पास 8.1 है, सॉरी 8.1 है मेरे पास, तो वो चलेगा सर? वेब पैक 8.1
चलेगा सर. मोस्टली ना सर विंडोज के वर्जन के साथ ज्यादा कुछ प्रॉब्लम आता नहीं है, बिकॉज आई एम इंस्टॉलिंग ऑन विस्टा, तो आप समझ सकते हो कि विस्टा पे मुझे कोई प्रॉब्लम नहीं है.
ओके, 8.1 पे भी सब फंक्शनलिटी रहेगा ऑलमोस्ट?
सर टूल का फंक्शनैलिटी विथ विंडोज चेंज नहीं होता है. ऑल टूल्स विल बी हैविंग ऑल द फंक्शंस व्हिच आर रिक्वायर्ड. ये सारे वर्जन का सबका फंक्शनैलिटी सेम ही है. एडिशनल चीजें ऐड की जाती है, कम नहीं की जाती है.
हाँ, करेक्ट.
और वो भी जो है ना, वो मोस्टली एडिशनल थिंग्स मींस स्पीड में थोड़ा चेंज होता है, या उन्होंने कुछ एडिशन किए होते हैं, सो आईपीज ऐड होती है, वो होता है, ज्यादा कुछ नहीं.
Yes, sir.
So don't worry about it. There are few tools, lab tools are also available. एक तो ये 14.3 का ट्राई करो. This otherwise this 12.20123 ये भी वर्जन चलता है. फुल विंडोज फुल इंस्टॉलर, ये 6.2 GB का ही इंस्टॉलर है. तो यहाँ ISE का स्पेशल इंस्टॉलर मिल जाता है अलग से. ये विवाडो एंड ISE दोनों का इंस्टॉलर है. टेक ओनली दिस इंस्टॉलर. ये 14.2 सीरीज. दिस इज अ विवाडो 2012.3 एंड ISE 14.3. ये वर्जन लो. एवरीवन प्लीज टेक दिस विल वर्क. मोस्ट कंप्यूटर पे ये चलना चाहिए.
Sir, can you repeat? Vivado and ISC design suits. Okay.
012.3. ये ट्राई करके देखो. बिकॉज आई नेवर फेस दिस प्रॉब्लम, सो आई डोंट नो एग्जैक्टली की. और जिन लोगों के पास XP के वर्जन है, ISA फाउंडेशन पैक ये सबसे आसान पैक है इंस्टॉल करने के लिए. ये हायर इस पे भी इंस्टॉल होता है बाय द वे.
Sir, again here, which one to click? Like there are many options. Windows वाला, हाँ, that is all.
Windows वाला. Select Windows वाला पैक. एंड जिनके पास एकदम लोएस्ट वर्जन है विंडोज के, दे कैन यूज दिस 9.2 ISE फाउंडेशन. दिस इज द बेसिक पैक. ISE वेब पैक, वी कॉल दिस एज ISE वेब पैक 9.2i. सबसे आसान पैक है इंस्टॉल करने के लिए, बट ये शायद विंडोज 10 11 पे इंस्टॉल नहीं होगा. ये बहुत ओल्ड वर्जन है. बट जिनके पास XP है या विस्टा वर्जन है, they can use that. और जिनको अभी और ज्यादा प्रॉब्लम आ रहा है, they can use this 2021 वर्जन, बट इसमें ISE नहीं है. प्रॉब्लम ये है.
Can you once show the EDA playground?
Yes. Yeah. I will go to the EDA playground. Just a minute. So the people who are not able to install today, they may try this EDA playground. Here you have to log in. Okay. I will copy the link. EDA playground. You can see this edaplayground.com. So here you can write your code, actual code, Verilog code. Here everyone has to select the language they wanted to code. So system Verilog or Verilog. UVM, OVM, none. Select the tool you wanted to use. So there are multiple tools available, but the tools we are using today, those are not available here. So you can use this tool. iCarus Verilog or iCarus Verilog 9.6 or 7 or Mentor Precision. Any tool you can select. Mentor Precision you can select, or you can select iCarus Verilog, and you may write code here and just run the program. It will do the same thing. And for watching the waveform, open EPS wave after simulation. I will show you how it happens. Just a minute. I'm having the login ID here. Hopefully it will open. I think password is wrong. Yes, now it is okay. So will you all be able to see this? Is it visible?
Yes, sir.
Yeah. So now in playground, I'm having few codes. So I can show you one of the code filter I have created. So you can see if I can create a FIR 3-tap filter, you can write any code, but it is written in VHDL. It is not written in the Verilog. So the basic code also you can run so far, and you can select the family also. Accordingly, it will do. So Xilinx FPGA, whichever you wanted to use, you may use, and it will do the work and run. You don't have to do these kind of things. Something is there. Okay. It was blocked. Now I have unblocked it, and I'll try to run it again. Hopefully it will work. Yes. You can see this. This is the waveform I wanted to see. Get signals. Append selected. Append all. You can see this. So you can see all the waveforms here. There will not be any problem. Okay. So ये तो बड़ा प्रोग्राम है. आपको इतने बड़े प्रोग्राम करने भी नहीं है. आपको सिंपल प्रोग्राम करने हैं. What you have to do is, only thing is that सिंपल प्लेग्राउंड आपको एक स्टार्ट करना है. एक छोटा सा प्रोग्राम लेना है. यहाँ आपको प्रोग्राम लिखना है. क्रिएट अ फाइल. दैट्स इट. Or you can upload a file also. So simple, create a file, give a name to the file. So I can give and.get.v. So create a file. It will create a file. You may write something like this here. Whatever I write there, you have to write here. Module A, module and get in this way. A, B, C. That's it. You can write something like this. Okay, sir. Is it clear?
Yes, yes. Thank you so much.
Excuse me, sir. How you have selected that family?
This here?
Yeah.
Madam, actually, now when you have to use the Mentor Questa, you have to write a script. For iCarus, you don't have to write the script.
And sir, can we able to generate a bitstream file using this?
Yes, madam. There are synthesizers available. You can use some of the synthesizers from this. You can see there are few synthesizers available. Tools and simulator. From that, you have to choose one of the synthesizer. Just a minute. There is a Yosis synthesizer available. I think here is not showing. Simulators and synthesizer, everything is available. Okay, synthesis, you can see this. Mentor Precision or Yosis. You may select Yosis and then synthesis can be possible.
Okay, so student can generate the bitstream file online at home, and if they can carry, they can check the output on the actual hardware. No, is it
Okay.
possible?
Yes, madam. It is possible. But Yosis doesn't work for the VHDL. For Verilog, it will work. Okay.
Okay. Thank you, sir.
Let me check इस पे होता है क्या? It works very well. There will not be any problem. See, I am trying to synthesize. Yes, it is synthesizing. See this. You can see this.
Yes, sir.
See, it is showing the complete information. It is showing कि global buffers कितने हैं, क्या है, सब चल रहा है. So I tried this earlier. It works very well. Only thing is that कि इसका direct setup available नहीं है कुछ भी.
But sir, then how to download bitstream file? वो कहाँ पे सेव होगा सर?
वो मैडम बाय डिफॉल्ट ना आपके इस पे डाउनलोड, इसका बिटस्ट्रीम का मैंने देखा नहीं है, मुझे देखना पड़ेगा एक बार ये क्या है. बट ये सिंथेसाइज करता है पूरी चीजें. इट डज एवरीथिंग.
ओके सर.
इसका बिटस्ट्रीम का क्या है मुझे पता नहीं अभी के लिए. तो आज के लिए ये काम कर जाएगा, बाकी वाली चीजें हमें थोड़ी देखनी पड़ेगी.
ओके सर.
ओके.
Yeah.
I hope for tool most of the things are clear now, and we can start the session at 12:45. Okay. So is there any other question?
There is one request. Actually, sir, I'm getting login request from the students also. So I would request everyone not to share this link to students. Yeah. Thank you, sir.
Okay. Yes, any other question? So shall we finish the session? The first session? Ayush? Yeah, will you be able to put that on hold? Streaming? Yeah. Yeah. So we will join back at 12:45 after 1 hour, and I will start directly the programming session. And you are till then try to install the Xilinx if possible.
Okay, thank you, sir.
Okay. Okay, then you may leave now. Thank you very much for joining the session.
Thank you, sir.
Yeah.
Thank you, sir.
Everyone, now you can download course 1 week material, week 1 course material also from the website. I have shared the link for that. So you will be able to download program, UCF files and everything. So whatever we will do today, that is shared there. So you will be able to see, if you are not able to cope up the speed, then you may use that material today also. So now we will start. We will not wait much more time. So I will share my entire screen and I will show what we are going to do. Okay. So shall we start?
Yes, sir.
Yeah. Okay. Okay. Now here you can find in week 1 YouTube streaming link and the course material. So in course material I will show what I have added, so you will be able to download everything whichever you needed. Okay. So here all the Albert V2 docs are added. In this, all the docs related to Albert V2 are there. You can see here. In the folder, you can see the driver design UCF file. I think it is uploaded multiple times because of some error. And FPGA PPT is also there. I will update PPT also soon. Then there are some UCF file which we require today, and EDA playground script if somebody is using EDA playground. So if they need script, that script is also added here. This is a Albert V2 base UCF file. What is this and when it is required, I will let you know. But after tomorrow's session, you will require this. These are the Verilog programs which we are going to do today. So I have added all those programs, but don't take it as it is because I will show you how to write a program. Okay. So this is what you will get from the link. And EDA playground, I'm just keeping on, but I will use when it is needed. Okay. So before starting anything, I will share few basic things with all of you. So please remember, many of you may be knowing very good C and C++ programming. So it is very tempting that if you see the simple hardware, you start programming. This is the worst practice anyone can follow in the VHDL or Verilog programming or a VLSI design. In VLSI design, do not program anything without design. So keep it as a practice. There is no point in programming anything on Verilog. It might work, but still you should design. The reason is these languages are description languages. So what you design, that gets reflected onto the board or on the tool. So these are not the languages which basically shows only the functionality. Something runs on the hardware. So if your design goes wrong, everything goes wrong. Okay. So that's why I will tell. Right now, I'm doing very simple thing. So there is nothing very difficult we have to do here. So is Google Jamboard visible to everyone? The first program we will write will be full adder. Okay. Okay. So I will write it as full adder. So why I am doing this, you will come to know very easily after we finish the code. Okay. So what I will do is I will write a full adder. So I have a full adder. Just ignore my designing skill. Okay, full adder. It will be having 3 inputs. So I will write it as, I will write later. So 3 input and two outputs. You should design like this with any design if you are doing. So this will be A in, then B in. You might find this very easy, but it is important to understand the technique, because if you understand the technique, the same thing you can do here in the programming. Programming is not very difficult part if you do proper design. If your designing goes wrong, everything goes wrong. Carry. Okay, so simple. We have to design this full adder. So these are called as inputs and these are called as outputs. So these inputs and outputs together called as a ports in a Verilog, and this is called as a module. Okay, so we have to write a module which will be having inputs A in, B in, C in, and sum and carry. So we will start now. So what you have to do is go to Windows Starter. So there might be problem ki your tool is not opening. So what you have to do is go to the Windows Startup, click on the Xilinx tool and click on 32-bit Project Navigator or 64-bit Project Navigator. If your 64-bit Project Navigator is not working, click on the 32-bit Project Navigator and that will work. Okay. So open the Xilinx. I already opened the Xilinx. So you will find something like this. You might not have any screen there because in my case, the program previous project is open. So that's why my screen is like this. You will find nothing here. Okay. So we will start fresh project, but before that, you may open this. Okay. Have you all opened the Xilinx? Please open the Xilinx. You first finish opening the Xilinx. I will give 2 minutes time. It will take time to open the Xilinx. You will find the coding is very easy. Everyone, please open the Xilinx. Once you are done with the Xilinx, if you are using the EDA playground, go to the EDA playground and create new playground. Simple. Here. You can create. Here you just have to click plus sign and new playground will open. Okay. Click on the plus sign and the new playground will open. By default, there will be design.vhd or v file. You have to select the programming language as Verilog. So I will select it as a Verilog and start a new playground. You may try something like this. Here, you can add a new playground here in this case. Do it. So if you are using a playground, you may try.
Sir, in the playground, how to change from VHDL to Verilog, where it is?
Yeah, on the left hand side, madam, there is a tab.
Sir, are you there is screen?
Sir.
Yes.
Okay, sir, I got it.
I'm sharing the screen.
Sir, are you sharing any screen? I cannot see any screen, sir.
Yeah, because right now I am on the meet. Now you will be able to see. Is it visible?
Yes, sir. Yes, sir, it is visible for me.
It is, yes, visible.
Yeah. So if I click on the D flip-flop, you can see like this. This is my screen. Okay, here on the left-hand side, you can select Verilog or VHDL, whatever.
Like it.
Okay. Here you can find multiple examples also. If you have it. Okay, so we will start now. Okay, so what you have to do is here first. यहाँ आपको एक project का कुछ तो दिखेगा number. So what you have to do is you have to create. First, go here, File, New Project. Click on File, New Project. Everyone, do it. Okay. then select the path. So I am selecting a path, give path which is not on the C drive. Okay, give a path which is not on the C drive. So I am giving a path, prototyping with FPGA, make new folder. I will write name as adder. Okay, so I am creating a file into the adder. Okay, see this.
Hello, sir.
Yes.
Hello, sir. What if we create a project in C drive? Because in my case, if I am trying to do it in another drive, it is closing automatically. That webpack.
Yeah, that is probably you have opened
Yes,
Xilinx
sir.
from
Same,
the.
same.
Have you opened the Xilinx from the desktop?
Yes.
Open it from the startup. ये Xilinx की प्रॉब्लम है, इसको सॉल्व कैसे करना है मैं बाद में बताता हूँ. इसको चेंज करना पड़ता है. ये मेरे पे कंप्यूटर पे आ रहा है. Okay, open it from the startup.
Same thing is happening with me also.
Open it from the startup. Startup पे जाइए, वहां से 32 बिट या 64 बिट ओपन कीजिए. 64 बिट में भी ये प्रॉब्लम आ रहा है कई जगह. 32 बिट अच्छा चलेगा. ट्राई करिए. Please open from the startup, go to the Xilinx Designs tool and 32-bit project navigator. Open कीजिए उसको. Then follow the procedure. और किसी के इसमें प्रॉब्लम आ रहा है ऐसा? Anybody is having this problem, the same problem?
यस सर, सेटअप में प्रॉब्लम आ रही है.
Yes, sir.
टूल्स कहीं दिख नहीं रहा है सर. बस वो विंडो खुल रही है. हाँ, वो Xylin डाउनलोड कर लिया सक्सेसफुली, बस खुल गया विंडो. एन एरर सेटअप ऐसे कर.
क्या एरर है
नहीं दिख रहा.
हाँ,
Same error, sir. The window is getting closed.
Window is getting closed. एक्चुअली फॉर दैट इसलिए मैंने बोला कि ये स्टार्टअप में जाइए, वहां से ओपन कीजिए. ऐसे जाके ओपन कीजिए.
Yes, sir. If we are using that startup, then it is not creating any problem. That is working fine.
Yeah, that is what I am telling you. कि डेस्कटॉप से ओपन मत कीजिए, और डेस्कटॉप से चलता नहीं है, प्रॉब्लम क्रिएट कर रहा है फॉर डेस्कटॉप. ये मेरे भी कंप्यूटर में करता है, मैं भी करूँगा तो ये हो जाएगा ऐसे ही. बट आई अंडरस्टूड कि इसको एक सॉल्यूशन है, वो अंदर जाके उसके एक फाइल में एक चेंज करना पड़ता है. बट इट टेक्स टाइम. दैट्स व्हाई नाउअडेज पीपल यूज विवाडो. बट अभी मैं विवाडो सिखाना से स्टार्ट करूँगा तो वी नीड लार्जर बोर्ड्स, विच बोर्ड्स आर नॉट अवेलेबल विद अस.
सर उसमें ऐसे दिखा रहा है एरर डिटेल्स कोड ई फेल कंपोनेंट कंसोल रैप इंटरफेस, ऐसा आई कंसोल लाइक दिस इट इज शोइंग.
फॉर व्हाट? इंस्टॉलेशन कंप्लीट है आपका?
हाँ कंप्लीट है, सक्सेसफुली कंप्लीट. स्क्रीन भी आ गई.
लाइसेंस फेच किया आपने?
लाइसेंस जो
आपको लाइसेंस फेच करना पड़ेगा. ओके एवरीबॉडी.
सर क्या लाइसेंस? प्लीज.
वेबपैक का अगर लाइसेंस है ना तो बाय डिफॉल्ट हो जाता है वो इंस्टॉल, अगर इंटरनेट ऑनलाइन चालू है तो.
हाँ इंटरनेट ऑनलाइन है सर, वो वेबपैक वाला ही करा था, बट लाइसेंस का उसमें कुछ था नहीं.
ओके, एक देखिए यहाँ जिन लोगों का लाइसेंस का प्रॉब्लम है ना, सी दिस. सो जनरली आपका लाइसेंस चल रहा है कि नहीं यहाँ पता चलता है. सी दिस, गो टू द Xilinx डिजाइन टूल्स. In that, manage Xilinx licenses. Click on this. I will show you what you have to do here. So कई लोगों का ये भी प्रॉब्लम है, उन लोगों को पता नहीं है. आपको what you have to do is you have to go on to the Xilinx website, download Xilinx license, webpack license मिल जाता है, और you have to ask for a webpack. Okay, so look at this, manage licenses. here you have to load the license which is available with you. It might come on your website, sorry, your Gmail address or in your account, or you can acquire from this. Start now 30-day trial. But यहाँ bitstream नहीं बनती है. So you can use get free Vivado IAC Webpack license. Click on this. I have a purchase license, so I'm using a purchase license. So you may use get free Vivado IAC Webpack license. You may try this. Please try this. Get free Vivado IAC Webpack license और check करो. जब आप license check करोगे ना, you can see I am having a plan ahead permanent license. So you can see things like this. If it is working, then it is fine. See, I am having these permanent licenses. You will be able to see. You can see the node locked. So that means it is locked with my one of the computer. Okay. So your computer के साथ locked है. I hope everyone has finished this. So please open Xilinx and put the name adder. So यहाँ तक आ गए सब लोग? Have you all come up to this point? Is it done?
Yes, sir.
Yeah. Okay. Now click on next. Okay. So this is next. Here what you have to do is property name value as it is, none specified, product category all. There are multiple categories. From that you have to select Spartan 3A and Spartan 3AN. Okay. Select Spartan 3A and Spartan 3AN. And in that you have to select. Yes.
Hello, sir.
हाँ.
Hello, sir. There is one doubt. In my college, we have Spartan 3E.
आप Spartan 3E select कर सकते हो, but आपका UCF अलग आएगा. Right now I am using Spartan 3A. That's why I am showing Spartan 3A. You may try Spartan 3E, but you have to write your own UCF then.
Okay, okay.
Right now I am showing with according to the UCF. You may next time use or you may download the Spartan 3E UCF.
Okay, sir.
Okay. So no problem. You may select accordingly. So whatever board available with your college, you may select that board.
Okay, sir.
UCF का प्रॉब्लम मैं एंड में सॉल्व करके देता हूँ आपको क्या करना है उसके लिए. ओके. या.
Okay, sir.
Yes.
Sorry, sir, for disturbing. Actually, my students were trying to install the Webpack, but they are saying that after 92%, it is getting stuck.
Because I'm telling you, most of the people are using the firewalls, and वहाँ क्या होता है 92% means they are installing some drivers, which is stuck.
Okay, I'll ask them to check.
और उनका space full हो गया है. C drive का space check करने को बोलो.
Okay, sir. Thank you.
Because it takes 20 GB to install, 17 to 20 GB to install.
Right. Fine.
Installation space उसका 17 GB है.
Yes, sir. Even the Webpack also takes that much?
Yes, 17 GB.
Okay, sir.
All the latest version takes around 17-18 GB. It is like a MATLAB. Heaviest versions.
Okay, sir. Okay, I'll ask them. Thank you.
Okay.
Sir, I am facing the same issue, sir. It is getting close. Can I share my screen, sir?
What is the issue, madam? What is it?
When I am opening from the startup, that IAC 32-bit command. So that it is opening, but once I give the partner, it is getting closed. Even I have checked the managed Xilinx licenses. There the path is given properly.
Okay, madam, आप 64-bit use कर रहे हैं या 32-bit use कर रहे हैं?
32-bit.
So आप 64-bit भी एक बार try करके देखो, because this problem can be solved with some remedies. ये directly solve नहीं होता है problem. It is problem with the Windows actually. I searched once on the internet. There are some things we have to do alternatively, and that stops. But for that, we have to remove some files. Basically, it is because of some background files.
Sir, if I go to ISC designs with 64-bit command prompt, the black window, command prompt window is opening, correct?
No, why are you doing that? You have to open Project Navigator. What are you opening?
So if I'm doing that now,
see this here, you have to open only 32-bit or 64-bit Project Navigator. Any one of this. ये नीचे वाला ISC डिजाइन सूट नहीं ओपन करना है आपको, ये ओपन करना है. प्रोजेक्ट नेविगेटर ओपन करना है आपको. 32-bit or 64-bit. Probably you are opening the command prompt.
Yes, sir. Yes.
Okay. Okay then. So this is device technology. So what does it mean? Xilinx Core 3S Spartan 3 50A is the series. Okay. So this is Xilinx Core 3S 50A series I am using. TQ144 is the package name. So and -4 is the speed grade. Okay. The speed grade, whatever the speed grade is higher, that is faster. So here -5 is faster than the -4. Okay. In Spartan, there are two speed grades, -4, -5. So -4 is slower than the -5. But now I am having the -4 boards. Okay. You may select the synthesis tool as VHDL Verilog, iSIM as it is. If mistakenly model SIM is selected here, make it iSIM. Okay. And preferred language, you may select Verilog. Click on here, preferred language Verilog. Here you can write whatever you want. It doesn't matter actually. Source analysis standard VHDL 93. So it is a VHDL 93 standard. So don't worry about it. Okay, have you all finished with this? If you have different kind of boards in your college, select accordingly. I am using this. These are the new Matter boards. Okay, click on next. And then what you have to do is finish. That's it. The project is made. So if you are able to see, if you are completed the project, you will be able to see the FPGA name as a project name. See this. Here you can see. This is called as a project area. This is a basically implementation area. This is a command prompt. Here you can see console, errors, warnings, find in results, and this is your text editor. It is a menu. So how to use all these things, how to code, where to find syntax, I will teach everything today. I will tell everything about it. Okay, up to this, everyone has finished. Shall we go ahead?
Sir, hello, sir.
Yeah.
So tomorrow will be there any session?
No, madam. Next session is on the Sunday. So you have a 1 week time to again watch this video and check. But there will be few assignments and videos coming in the upcoming week.
Okay, so next week will be the second session. Okay, thank you.
Yes.
Sir.
Okay. Okay, so shall we go ahead? Are you all done with this? Yeah.
Hello, sir.
Yeah.
Sir, one of my student is getting problem with installation. That is, installation cannot be performed. Please fix the issues before installing. Virtualization is not enabled in BIOS. Please enable before installing. Like this.
Madam, actually, I don't know what is this problem because few students are facing this problem, and most of them are not facing this problem. I will get to know this problem in next week. So up to next week, my website.
Sir, may I add?
Yes, sir. Please go ahead.
So during the we have to go into the BIOS setup. We have to restart the computer and we have to enter into the BIOS setup, and there is one option to enable virtual.
Okay. So they have not. enable the virtualization from the BIOS.
Yes.
Okay, sir, will you please put up that onto the, or I will ask student to put up. Are you
students
will
can
you be
do
able
that
to
because
put up that onto the stream?
Sir, I have put that snapshot of that error message in our group, mini project 2B group, WhatsApp group.
That's okay, madam. अभी सर ने solution बताया है, सर solution भी put up करेंगे उसका वहाँ.
Sir,
I will ask Ayush also to put up the solution. Ayush, have you understood the solution? What you have to do?
You have to enter into the BIOS setup. Means we have to restart the computer and we have to press delete button so that we can enter into the BIOS setup. And there is one option to enable virtual terminal, virtualization.
Okay, I think sir now it is recorded, so stream में सुनाई देगा अभी वो चलेगा. Okay, so the students who are facing this problem, please go into the BIOS setup, switch off the computer, restart the computer, and go into the BIOS setup and enable the option for the virtualization. Once you do that, again you reinstall this, the problem will not be there. Then it will work. So I hope now that query is also solved. Thank you, sir. Okay.
Yes, sir. Thank you.
Now we will start programming. So first we will create our program. So click right click onto the project. Go and click onto the project and right click. Okay. After right click, you will find this kind of window. Click on new source. You will be able to see this kind of things. Are you all able to see this? Select their Verilog module. And click here, full, write the name full adder. Okay. Is it done, everybody? I'll wait for 2 minutes.
So here the project name should be same as before, means, or
madam, this is not a project name. Now we are in one project, we are making a new file.
Okay.
Project now remains same for all the designs which we do.
Okay, so this can be different.
Unless we create a new project.
Okay.
So now we are working on the adder project. In that, our first module will be full adder. So this is first file we are creating. Okay. Everyone done with this? See, you don't have to do any programming. You will come to know very easily. You can do everything. Okay. Click on next. If you click on next, you can see the port names. So we have already seen on the Jamboard, we have created the 3 ports. You may write A in, comma, E in, comma, C in. And direction is input and sum, comma, carry. This as output. That's it.
Sir, B is not typed, I think.
Yeah. Actually, there is problem with my computer's keyboard. B and N don't get typed very easily.
Same with me, sir. B and N.
It is not working. So sometimes it doesn't get printed. Okay. So everyone done with this? Later on also you can modify the program, but this is an automated way to create a program. Then click on next and finish. That's it. The program is created. Here also you can modify the program if you want to modify. So you can change the name if you want something like that. Full adder, writing again. So you can check this. This is called time scale. In this time scale, the program will run. That means simulation will run. You can put your files information here. These are used for the comments. These slashes, okay, double slash. You may try this. So this is a comment. So I can write on the top here. This is called module, okay. Input and output, these are called ports. This is a file name. Now I am writing my program. So I have to write assign. One more thing, please remember, Verilog is a case sensitive language. So you have to be very careful while writing a program. It is a case sensitive language. Okay. Assign sum equals to, today I am not going into details of the syntax. Today we will be writing simple programs, so you will get to know the tool and you will be able to do the programming. That's the purpose. So I am not very much into the syntax, at least for today. Okay. So I will explain what is I'm writing, but most of the things I am doing for understanding. So, okay. The equation for the sum, what is the equation for sum? I am implementing this equation. I will write here. So sum is equal to A in and A in XOR B in XOR C in. This equation I have to implement. And for carry, I will implement the equation A in, B in, or B in, C in, or C in, A in. So that means A, B, B, C, C, A. That is the equation. Simple. I am specifically giving the suffix this in. I'm postfix. This I'm using A in, B in, C in, because this will show these are the inputs. You may write sum out, carry out also to tell these are the outputs if you want. Okay, so here I have to write. So and keyword is used. As I said, it is very close to C programming. So the same kind of operators you may use. So B in, and you may write code like this. Okay. C in and in, semicolon. So after every line you have to put semicolon, and when you are writing a statement, parallel statements, then it is you have to write assign. Okay, so this is the data flow programming. This is called as a data flow programming. We are implementing the equation. Basically what we are trying to do is we are implementing the truth table. It is following the truth table.
Sir, you wrote the equation for carry in the sums.
Oh, sorry. Yeah, sorry. So I will make it carry. And assign sum is equal to A in XOR के लिए cap. You may use cap. Shift 6. B in XOR C in. Semicolon. Okay. And by the way, in the Verilog programming, see in the VHDL C programming, what happens is if you write these kind of statements, the statements will get implemented one after another. That means first carry will implement, then sum will implement. In case of a HDL program, both the statements will get implemented simultaneously on the same time. Okay, so this is a parallel statements. So that is the difference between the C programming or the all software programming and hardware programming. In hardware programming, everything is parallel. Here, we can do sequential programming also, but the technique is different. I will talk about that technique in next week. Today, we will only talk about the simple programs. and how to handle the tools, how to use the tool, what are the techniques for it. So we will talk about that, how to write a test bench. So once you are used to with it, we will go in next week for multiple programs. So is it clear? Have you all finished up to this point? Please tell me.
So wait for some time.
Yeah, I will wait. Everyone finish up to this point. If you have any question, please ask.
Sorry, instead of that symbol, we write and also, no? The and symbol.
Yes, sir.
Okay.
One more thing, the blue color, whatever blue color you are seeing, that is the syntax. And other black color that you are writing. Okay. So this is part of a syntax. In module, assign, output, input. These are all syntaxes.
So in playground, we directly have to write this code, na?
Yes, sir.
Okay,
what
sir.
you have to do is, I will show here. I will copy this code directly. Control C. You can do something like this here. You may try something like this. Other create file, and you may write something like this. That's it. And you may check the tool, whichever tool you want to use. iCaras you may take and open EPS wave. Okay. So if you run, see what happens. Will it work? Exit code expected, received 1. Syntax error. There is syntax error. Where is the syntax error? SV3. Okay, ये इस पे error है. Actually ये code यहाँ copy होना चाहिए because design.sv is the top module here. Every time. Probably that is the reason. Let's see what happens. Two errors. Unknown type module, adder 1 bit. What is happening here? Okay, it is checking this test bench module. We have to check this module. So इसको हमें check करना है. Actually नया आप जो बना रहे हो उसमें copy करो और run करो इसको, चलेगा ये. Test bench I wanted to delete. You may start with the new test bench and new code. So this will work. Okay, anyways, I will come back. Yeah. So everyone done with this coding? So shall I go ahead?
Yes, sir.
Okay. So now what we have to do is, we have to check whether this code is working. So there are two things. One, we have to check it functionally, whether functionally it is working or not. The second thing we have to check is whether it is synthesizably working or not. So पहले हम लोग इसका synthesis करके देखते हैं. और we will do simulation first. So for simulation, click on the simulation tab here. You may click on this. Okay. So it will go into the simulation. Now I want to simulate this code. For that, what I will do is, again, I will click on the project name and I will click new source again. Okay. And here you may write Verilog test fixture. And you may write the name full adder TB. Write it down. Full adder TB. Go to the new source in simulation, and here you have to select Verilog test fixture. So that means you are writing a Verilog test bench, and you may write the name full adder TB. In Vivado, test bench facility is not there. You have to create your own test bench and add it, and then it will simulate directly. It has a simulator, but the test bench generation will not happen. Test bench works, but the generation will not happen. So whoever is using Vivado, they may please remember that part. It won't create the test bench. So generally, I prefer write code into the ISE project navigator. Then I shift it to the Vivado and I synthesize and check everything from the Vivado. Vivado has all the capabilities, but somewhat advanced tool. It is a somewhat advanced tool. Okay. Okay. Then I will click on to next. You will find the associate source. So full adder ko click karo. Next and finish. That's it. ये अपने आप टेस्ट बेंच बना लेगा. See, the test bench is there. You can see here. Now what is it? So reg is like register. You can register the inputs A in, B in, C in. Please remember, in the test bench there will not be any port. All the registers and wires are there. Wire is like a signal. Wire means wire, signal. You are connecting the wires. So two modules या inputs को connect करने के लिए test bench है. So what is test bench exactly? See here you can see the Jamboard. Please observe this. So when I write a test bench, something like this happen. So here I am creating a test bench. So test bench is like one entity I'm creating above the full adder. Now I create inputs like this, A, B, and C. Now I connect this input here. I connect this input here, this input here. Then I connect some outside and I will make it sum. Okay. I will call carry outside and I call it carry. So what I'm trying to do, I am giving input from this. This is A in. Here I'm giving input. This is B in. Now these are the actual pins on the board. These are the actual pins on the board. But here it is a virtual environment which we are creating, which will be having signals. So I'm forcing these signals which will connect to the board pin and it will get outside. So right now no board is connected. So only the hardware is getting connected with this entity and the sum and carry output we can observe. So that is what I am doing here. So this is called test bench. Okay. This is test bench. Okay. So I hope everyone understood what is test bench. So that's why in test bench there is no port. Now, what we have to do, we have to instantiate the adder module into the test bench. We have to force these values, okay? So adder module, you have to call like a function into the test bench. So you are calling it as a function or this is called as a instantiation. So instantiation of the full adder UUT. So dot A in means the current port. You are mapping it to the A in. Okay. So ये port आप इस port को map कर रहे हो, this port. Okay. Then you are mapping B in to this port. Then C in to this port. Okay. So this is how you have to do it. Then sum and sum carry and carry. Then initially all the values are 0. I have to force all these values now. So up till now, up to this point you finish, then I will tell you how to force and how to check the simulation. Please do it. You finish up to this point. Then I will show you how to do the next part. It's very simple. Everybody done up to this point?
Yes, sir.
So shall
this has been already created.
Yes.
This was already there, no? Yes.
Yes, it is already there. You don't have to do anything here.
Sir, excuse me, sir.
Yes.
I'm using Vivado. So do I need to type everything
Yes, in Vivado you have to type everything.
As it is, I can type, no? Because
Yes. You can type as it is. Vivado test bench नहीं बनाएगा ये problem.
okay.
इसलिए मैंने ये Xilinx यूज किया है इसके लिए, ISE यूज किया. So you have to type everything. So the solution I can give you is I have shared the material. You may download the test bench from there. Okay, madam?
Okay, so where you have uploaded that material?
Madam, I have given the link in the chat box, as well as I have uploaded, go to the website, there I have created a link.
Okay, sir.
Okay. You may try that. I hope everyone is finished up to this point. Okay. Then we have to write something like this. You may write something like this. Always $5 in equals to not of aim. What does it mean? Will you be able to identify what I'm writing?
Just creating this clock pulse for inputs.
Yes, for all the inputs, I am creating a test bench. Initially, all the inputs are 0. Remember that. Okay. So now look at this. I will show you what exactly I have written. So this is a simple test bench logic. I'll show what I have exactly created. So what are the inputs? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. This is A in, B in, C in. Okay, so this is in. Okay, B in, A in. Now see this. Here, this is changing after every 5 seconds. Okay, so this is 5 nanosecond time. Every 5 nanosecond it is changing. When it is changing 2 times, it is changing 1 time. So this is 10 nanosecond timing. Okay, this is 10 nanosecond. And when this is changing 2 times, it is changing 4 times. So that means it is 4 times changing. So this is 20 nanosecond time. So that's it. You have to negate it, 0 to 1. So that's why I'm writing negation. So after 5 nanosecond, A in will switch. So here in this case, I will make something like this better way. So it will match the thing. So A in. Is it clear? Is this? सबको समझ में आया ये? What I have done, or one more explanation is required?
So it is clear.
Yeah.
Sir, here we have not directly put the value like 001010 that in VHDL what we are doing like that.
Sir, we can do that, but in VHDL also we can write this kind of codes. We generally do not write 000110. That's a very lengthy test bench.
Okay.
In test bench, we try to reduce logic as much as possible.
Okay.
Programming, basically. Ultimately, it will do the same thing. We can, here also we can do that kind of thing. I can write C in, wait for 5 nanosecond, then that is 5 nanosecond delay, then again join and forth. There are some statements which we can use. But it is not required when we can do it with a simple code. Okay.
Okay.
So sorry, you have to write this outside the block. Huh? You may write here. Please write here. And what always suggests, it will repeat always after 5 nanoseconds indefinitely, because we have not put down any time. Okay. Now click on the full adder TB, go to ISC simulator and simulate behavioral model. That's it. Click on the full adder TB, go to the simulate behavioral model and simulate. Yes. See this. Simulate होता है क्या check करो. See this, it is working. You have to click here zoom to full view if you want to see the waveform. See this. Click on this, zoom to full view, because it will show you the complete straight lines. So zoom to full view. Now how to observe the output? I will. Yeah.
Hello, sir.
Yes, ma'am.
Sir, I'm getting the error. Failed to link the design. Simulator. Simulator 861 failed to link the design.
Madam, probably आपका ये जो name है वो check करो.
Okay, sir. One sec. So which name?
This instantiation name.
Full adder.
Here it is full adder. और आपके जो full adder में क्या नाम लिखा है वो देखो. Test bench में और इसमें क्या name है देखो.
Test bench and the initial .v file, na? Code file.
Yeah.
Or
yeah. Here this name. This name.
Module. Okay.
And this name should be same. You have downloaded my test bench, I guess. Their name is different.
Okay.
If you have downloaded. If you have not downloaded, then the thing will be okay. Is it working for everyone? Please tell me.
Still, it is still showing elaborating.
Yeah. It will take time.
May take time.
Sometimes it is at the start, or if multiple things are there, then it creates problems, some such kind of problems.
Sir, how do you change that file name?
Which file name?
That project name and the test bench, this one.
Here?
Here I'm getting the error. That is your process simulate behavior model failed.
What is the error? Sir, click on this error, then you will come to know the error. And click on that error, reading the error. After reading the error, click on the error, it will go to the...
they are not taken that XOR and AND gate. I written in the XOR.
Okay, so you may use this. Because, sir, you can use here AND gate or XOR gate, but you have to write something like this. And take A, comma, B in. It will be like this. Okay. Because here what happens is, in case of a Verilog, those are not operators, those will work as a functions. So operator overloading होता है यहाँ generally. Functions की तरह काम करते हो. Probably that is the reason. Okay, everybody done with this?
Hello, sir.
Yes.
Sir, so I have created that .v file. So there the name is full adder, and while writing test bench, I have written name as full_adder.
तो मैडम वो full underscore adder कर दो उसको.
So can I change it now? Means that .v file name?
नहीं, .v file का name है वो test bench में डालो.
Okay, full adder. Okay, so same as.
जो अंडरस्कोर है वो निकाल दो आपके टेस्ट बेंच में. Because those names should match. You have to make change somewhere. या तो आप फाइल में चेंज करो या तो टेस्ट बेंच में चेंज करो. Somewhere you have to make a change. Otherwise the units will not match because it is calling a wrong module. And it is not finding that name.
Okay, so I have changed that name in TB. Now again I should simulate.
Yes.
Run. Okay.
Yes. Run simulation. Then it
Sir,
will.
how to see the waveforms of the output after writing test bench?
Yeah, madam, here you have to click on this. Click on the full adder TB and simulate behavioral model.
Simulate behavior.
Yes. Do it.
So now I changed that name and again run, but now getting different error. Cannot find design unit full underscore adder underscore tab in library work located at isim/work.
मैडम योर नेम्स आर नॉट मैचिंग. आपने कहाँ चेंज किया मुझे समझ में नहीं आया. मॉड्यूल में कहाँ चेंज किया आपने नेम?
So the test bench code, in test bench code I have changed.
ये चेंज किया या ये चेंज किया आपने? कहाँ चेंज किया? UUT से पहले चेंज किया आपने?
हाँ, एक मिनट. No sir, module name in test bench there is a module name.
That is what I am telling you. ये नहीं चेंज करना है. ये फुल एडर टीवी मॉड्यूल नेम है आपका. आपको ये इंस्टेंशिएशन नेम चेंज करना है. चेंज दिस इंस्टेंशिएशन नेम. आप ये मॉड्यूल कॉल कर रहे हो नीचे वाला, तो ये सेम नेम से कॉल करना पड़ेगा आपको.
Okay.
See, you are calling this module. So ये जो नेम है इस नेम से आपको कॉल करना पड़ेगा मॉड्यूल को. उसके all ports you have to match. Each and every port.
So only instantiation in that we have to change the name. UT
Yes.
before UT.
Here only. ये तो आपका टेस्ट बेंच नेम है ना. दिस इज अ न्यू प्रोग्राम. दिस इज अ न्यू मॉड्यूल. उसमें आपने ये मॉड्यूल कॉल किया है. It is like a function. This is a function name, new function name, test bench function name. In that function, you are calling this new function. So there is a mistake. वो sort out करो हो जाएगा. Okay. Everyone done with this? Shall we move ahead? Shall we go ahead?
Yes, sir.
Okay. So now, how to check this? See this. Click on C. So if you want to test कि your results are right or not from the waveform, there are different methods to check programmatically, but right now I'm showing from the. So click on the next transition. So now 0, 0, 1 sum is 1. Then 0, 1, 0 sum is 1, 0. 0, 1, 1 sum is 0, carry is 1. Then 1, 0, 0 sum 1, carry was 0. Then 1, 0, 1 sum is 0, carry is 1. 1, 1, 0 sum is 0, carry is 1. 1, 1, 1 both are 1. So my program is right. You may try like this. Okay. Okay, we will now switch off this. So I will finish this simulation.
Excuse me, sir. Could you please paste this code on EDA tool and show the output, because some students are not able to install the software, so they can use online tool.
Madam, I have already pasted everything. Just a minute. That's why, madam, I already gave the code. They have to download that code from website, so they can directly take that code.
Yeah, but we should know the procedure, how to check the waveform using EDA tool. So
okay. Save. System Verilog, iCanvas Verilog. Yes. Okay, some modules do not have time scale. So time scale is not copied here. Just a minute. I have to copy the time scale also. Okay. It is not opening actually because madam ultimately now I have not done coding for this today. I have to change everything here. That's why I given at the start only कि उसको download करके रखो. It creates lot of problems. Otherwise I have to add the script also. Okay, let's see if it works. Actually,
Hello, sir.
Yes,
Hello,
yes.
sir. Sir, for EDA playground, the test bench we have to write or it gets generated on its own?
No, we have to write.
We
Here,
have to write.
everything you have to write.
Yes.
It is not possible to do anything else here. Here, everything we have to write. So now I'm using mentor precision. That is the problem. I have to write a run.do file. Okay, I will write. That's why I'm not spending the time onto this. It takes time and we do not have that much time to spend. Just a minute. I have to select the code. Okay. Just a minute, wait. Run.do file I need now. I'll go to the website. So they can download UCF run.do file from here. Here the file is written. This run.do file. They need this file. Otherwise it will not work. Okay. I hope now it will work. Setup design. So here, setup design manufacturer Xilinx. I'm writing this Xilinx file. Add input file .r. Then
Hello?
write precision. Yeah.
नहीं रे मेरा वर्कशॉप चालू है इधर यूनिवर्सिटी लेवल का पूरा फैकल्टी नहीं है शायद आज बहुत लोग छुट्टी पे है
Okay, let's see. It might be having some error. Okay, it is synthesizing. So you have to write this file, and for simulators, select the simulator like this. So for a simulator also they have to write the file. I have to go through this. Right now the simulation is not working here. Just a minute. Because I have to show everything on the Xilinx. I have not prepared any simulation here. Yeah, synthesis is happening. I just wanted to go with the simulation. So let's see simulation chalta hai kya abhi. Synthesis is done. You can see the results of the synthesis. All the results of the synthesis are available. Only thing I have to do is simulation. That simulation is not happening right now because I have put down a wall that okay. Compile option. Okay, run. And simulation is not working. Probably that iVerilog is not working. I don't know. I have tested everything, but for iVerilog it is not working. Yeah, there is some error. I don't know what is that. Let me check. Yeah, it is not working. So there is some problem with the EDA playground simulation. They can write synthesize, but simulation is not happening. I have to go through that simulation part. I have not prepared that because I have done the Xilinx synthesis and simulation, everything today. Okay, anyways, we'll come back to this point. Next time I will try that because we do not have that much time. Okay, so now we will come back to the synthesis part. So everyone done up to this point? Please tell me. Is it done?
Yes, sir.
Yeah. Now go back to the implementation tab. Click on the full adder and click on synthesize XST. What you have to do is you have to click on synthesize XST. Everybody please click on the synthesize XST tab. Please do it. So you can see something happening in the, I will show here. You can see the synthesis is happening. I will show all the reports also. Okay. So are you all done with the synthesis? Click on the design summary. If you are not able to see, click on the here, design summary reports. Click on design summary reports. If you click on this, you will be able to see summary. Everybody please try this. Click on the design summary report. Design summary, synthesized. Check this. So now you can see total slices available are 704. Total LUTs available 1408. You can see exactly double. And only 2 4 input LUTs are used for the full adder. One is for carry, one is for the sum. So total 2 lookup table, that means 1 slice is used. Total bonded IOB is 5 because 3 inputs, 2 outputs. Is it clear? सबको आ रहा है ये? देखो. Are you all able to see this? Is the same thing happening on the EDA playground when you do run the run.do file? Is it happening the same file?
So if our device is different, it will show us different, no?
Yeah.
If the device selected is different,
Yes,
the
the design will also show different.
Yes.
But generally, synthesis will come same.
Okay.
Only slices difference will be there because lookup table will come same. दो ही आना चाहिए lookup table.
Okay,
Everyone
so
should
here
get
in my case, I'm getting fully used LUT 0 and number of slice LUT is 2.
Slice LUT is 2. Which device you have selected?
Something XC7 RTX from RTX actually.
RTX you have selected, then there might be a possibility. You will come to know. You are using Vivado?
No, sir. No, sir.
Then
I just
RTX
selected randomly whichever was there. I didn't take the specific one.
Okay, it doesn't matter. Actually, 4 input LUTs वहाँ जो है ना वो अलग type के थोड़े से. So slice difference could be there. When you do the implementation, you will come to know exactly. Okay, right now this is a synthesis report. So what we see in the synthesis report, I will show you. So if you go into the synthesis report, see here it is showing something. So probably waveform is also working for this. EPS wave reached maximum runtime. I have not put down a runtime, that's why it was creating the problem. Probably now it will work. Let's see. I have put down the 100 nanosecond runtime. Okay, there is some problem with the runtime option. Anyways, okay, I will go back to here. So in Xilinx, what you have to see is this point. The number of slices 1 out of 704. Device utilization summary, and here you can see how much is the speed of your device. So it is stating maximum combinational path delay of 7.02 nanosecond. So this much delay requires to get the output. So this is the speed of your device, current speed. But actual speed you will come to know after the map. Okay. So this is the real time taken by the CPU after the completion. Okay. So now you can see RTL schematic. Click on the RTL schematic. You will find the full adder and see this. Will you be able to relate with your paper pen structure? AND gates, 3 AND gates, 1 OR gate, then XOR. Look at this. If you click on the technology schematic, now click on the technology schematic. You will be able to see the technology schematic. See this. There will be 2 lookup tables. If you click on the lookup table, it will show you the internal schematic equation. That is what the equation we have implemented, I0 and I2 plus I1 and I2 plus I0 and I1. Then truth table will be there and then Karnaugh map. It should be like that. You can see there is a truth table, then there is a Karnaugh map. Okay. The same thing for the equation. This is for the XOR gate, truth table, and the Karnaugh map. So everything will be created automatically. You don't have to do anything. Up to this point, everybody able to see everything?
Excuse me, sir. So
Yes.
if we're using Vivado software, can you able to see such lookup table
Yes,
and
yes,
Karnaugh map?
Yes, madam. In Vivado also, you have to do the synthesize XST and click on the RTL schematic and the technology schematic. You can see there also.
Okay.
What you have to do is go to the design summary and in the synthesize XST, there is no synthesize XST. There is the implementation tab you can see.
Okay.
In the left hand side, will you be able to see the implementation tab?
Yeah, here implementation, run implementation options available.
Yes, implementation run कीजिए और उसके नीचे आप उसको प्लस साइन को क्लिक कीजिए, वहां आपको RTL and technology schematic दिखेगा.
Okay.
So these the same things are available there also. Only thing is that there is no synthesize XST.
Okay, sir. So can you please show me how you have got that K-map? You clicked on what option?
Yes, click on the lookup table
Right
and you
click.
will be able to see.
Acha.
Okay.
Okay, sir. Thank you.
So is there any other question?
Sir,
Yes, madam. Yes, madam. Uttara, madam, is there any question? Yeah.
yes, sir. Sir, the maximum combinational path delay comes out to be 7.027 nanosecond. Is it a pad-to-pad delay or some particular?
Madam, actually, it is not the actual delay. The pad-to-pad delay you will come to know after map. I will show that also. Before that, we have to give the UCF. Okay. So where UCF required, I will show you. First, so everyone, if you are done with this, click on the implement design. So it will perform some operations called translation, map, and place and route.
Sir, where to see the delay thing?
In the design summary, madam.
It is showing you only the tables, sir.
Madam, onto that synthesize summary नाम का एक option है देखिए.
Synthesize summary.
See here, I will show you.
Utilization summary.
Just a minute, madam. I will show you. See this. यहाँ click कीजिए synthesize report. Have you got the synthesis report like this?
Yes, yes.
Click on the synthesis report and go down.
Okay, sir. Thank you.
Now the map is happened. So this is your actual utilization. You can see this. So this is the actual occupied slices onto the board. And here you will be able to find out the delays actually. यहाँ भी actually हम लोगों ने timing constraint नहीं दिए हैं, तो timing constraint नहीं है तो आपको वो information मिलेगा नहीं. We have to put the timing constraint for that. Okay, we'll go to that part also. But wait a minute. So first finish the process of implementation. And now you have to generate programming file. The last step is generate programming file. Okay, click on generate programming file. Now the thing is that the programming file is generated, but we have not told to the board, to the tool, which pin will be bounded to which pin onto the hardware. So that means A-in will bound to some pin onto the hardware, but we have not told about that to the tool. So we have to tell the tool that A-in will be bound on this number, B-in will be bound on this number, C-in will be connected to this number, some will connected to this number of the pin. So basically, जैसे हमारे AND gate में OR gate में 1, 2, 3 pin number होते हैं. So in that case, on the FPGA also there will be 0, 1, 2, 3, 4 numbers, and from that you have to select one of the pin number which will be connected to the A-in, B-in, C-in, and sum and out, sum and carry, and then you will be able to see the result onto the FPGA. Okay, so for that, what you have to do is you have to add the UCF file. Okay, I will show you how to do it. So up to this, everyone has finished. Then we'll talk about the remaining part. Everyone able to do the implementation of the design or generate programming file? If it is done, then we'll go to the UCF file and then we'll perform the synthesis again.
Sir, can we see that programming file?
Which programming file?
So the file which we have generated using generate programming file.
Yes, madam, but right now that cannot be useful because it has nothing.
Okay, sir.
So that's why before that we will go for the adding UCF file. So here you have to write new UCF file. I will show you. यहाँ ऐसे click करो. New source, and on this you may write implementation constraint file. You may click on this implementation constraint file. You may give the name, or you may give the name something like this: adder underscore UCF, adder UCF. Okay. Now I am already having the file, so I am adding it instead of doing it. So you can click next. Okay. And finish. See this. Now this UCF file is coming under this. So now this file is blank. We have to write something into this file. So what I have to write, I will show you. So I have to give the input output pin numbers only. That's it. इतना हो गया तो हो गया. I'm having a adder UCF. I have shared the file with all of you. This file is given by the manufacturer. So on the manufacturer's website, you will get all these files. These are called as a user constraint files. These are available on the manufacturer's website. You have to go there and download those files. So go to the Pneumato lab and you will be able to download the file. For your convenience, I have shared the file onto the website. Okay. So now.
So is it in UCF folder on the shared material, course material?
Yes, madam. UCF file. वहाँ एक file लिखा है. Yes, वही file लेना है आपको.
Albert v2.ucf.
Yes, madam. Albert v2.ucf. But that is for the Albert v2 board. Huh?
Yes.
That file is for the Albert v2 board.
Okay. Then for this one, Spartan 3A.
That is Spartan 3A. वही Spartan 3A board. उसमें Albert v2 में Spartan 3A board है. So this is called design UCF. You can see this. So design UCF will be provided like this. Here they show all clock ka pin number. See how to read the UCF. Net clock 12 megahertz ka clock hai. On the Albert v2 board there is a 12 megahertz clock. Its pin number is 129. IO standard is LVCMOS 3 and period is 12 megahertz. Okay. Then these are for the VGA, blue, green, red, H-Sync, V-Sync. Then this is for the micro SD card. This is for audio jack. 7-segment display. You can see 7-segment displays. Enable, 3 enables and 7-segment display pins. Then LEDs. We need 3 LEDs, 2 LEDs. Okay. So I will copy this. Here, I will write. So I'm writing here. So I will write here, simple, sum, carry. That's it. Then I want what? DP switches. So I will take 3 DP switches. 0, 1, 2. I will take 3 DP switches. Watch this. And I have to give the name. In. You may also try B in and C in. That's it. So this is pin number 70, 69, 68. I will show you board after that. So save this. Now I have given the user constraint. You may please finish this, then I will show you the board. What I have done, you will come to know. Okay, everyone done with this? Everybody done with this? प्लीज डाउनलोड द फाइल डायरेक्टली. मैंने आपको फाइल शेयर किया है, वहां से आपको ये चीजें डाउनलोड करनी है. प्लीज चेक हियर. You have to download this file, Albert V2 UCF file, or if you are using different board from that site, you may download those files. Here you will get Verilog programs, whichever program, if you are not able to write the program. And then Albert V2 docs में आपको ये फाइल चाहिए. One driver you have to download. You need a driver. So driver not needed actually. आपको एक you need one most important thing. Okay, permission I am having from another. You actually need a downloader. Downloader, I think here not getting printed. One downloader is required. Okay, I will upload. I will check whether the downloader is there or not. You may download this completely. Everybody done? Please tell me. Is everyone done with this coding? इतना पार्ट सबका हो गया क्या? Are you all able to do up to this point?
Sir, searching for UCF file for my board.
Okay, बाकी लोगों ने अगर यही यूज किया है तो हुआ है क्या? मैडम आपका बोर्ड कौन सा है?
So I'm using Spartan 6.
बोर्ड कौन सा है? मिमास?
I'm using some Spartan 6 starter kit board.
आपके कॉलेज में वही बोर्ड है क्या?
This is my board that I have.
Okay, जिस कंपनी का बोर्ड है ना उसके वेबसाइट पे जाओ, वहां मिलेगा.
No, sir, I'm searching for it.
All other may write this kind of thing, then they will be able to synthesize it. You just copy it. Shall I copy it into the Google Meet? कॉपी कर पाएंगे आप उसको? वो ऑर्डर में आएगा कि नहीं पता नहीं. Have you all got this file? If you are facing a problem कि आपने अगर ये डिवाइस सिलेक्ट नहीं किया है, दूसरा डिवाइस सिलेक्ट किया है, तो आपको बेटर ऑप्शन बताता हूं मैं. यहां से जाके डिजाइन प्रॉपर्टीज सीधा चेंज कर दीजिए और ये एज इट इज कॉपी कर दीजिए. दैट्स इट. सिंपल. फॉर नाउ ओनली यू कैन डू दिस. यहां से आप डिजाइन प्रॉपर्टीज चेंज कीजिए. क्लिक ऑन टू द this point and design properties change कीजिए. I hope everyone is done with this part. Are you all done with this? Shall I move ahead? Shall we go ahead?
Sir, in the chat box, I have shared this line where I'm supposed to make changes in this.
Okay. Slide SW. You have to write the pin name here. A in B in. यहाँ लिखना.
Also,
you have to write something like this. net in LOC equal to P5.
Okay, sir. Thank you, sir.
Okay, you have to write something like this. Okay, I have joined from another camera. Will you be able to see the board? From another camera I have joined. Are you all able to see the board?
Yes, sir. Yes, sir.
Okay.
Yes.
So this is the board, and you can see these are the pins. We have mapped these first pins, 1, 2, 3 pin, these 3 pins. Okay. Now I have to download this code onto the board. Okay. So what I have to do, I have to go here. Again, I have to synthesize everything. Synthesis, I don't have to change. I just have to implement and create a generate programming file. So generate programming file tab पे click कीजिए. Click on the generate programming file. You will be able to see this. So the faculties which are having this board, they may try. I will show the result. Just a minute. Once the file is created, I will show you the result and the procedure. You can see the map is happening. Now here you can see the timing also. I will show later timing, how to see the timing. Uttara madam, I will show you how to see the pad-to-pad delay. Everything will be available. Yeah. See, later, first we will see the output, then I will show you the delay information. Okay, the bit generation is done. Now what I need is this one. Albert V2 config file. Okay. So Albert V2 config is basically a downloader. Xilinx downloader doesn't work with the most of the boards until and unless the board is bought from the Xilinx. So if you are getting board from another vendor, they will provide their own programmer. So this is a programmer. You have to select the COM port. So my COM port is 7. How to find out a COM port? Here what you have to do is, this is simple. I will show you how to find out which COM port the board is using right now. So go to here and manage. Basically from the devices you have to find out which port it is using, which COM port it is using. So it will show the control panel. From that you can find out which COM port it is using. So this is device manager. Open the device manager. Once you open the device manager, it will show the devices connected to your system. Here ports you can see. USB serial device COM7. Is it clear? ये कहाँ से देखना है? In the device manager, you have to see ports. So I have selected COM7, open file. Now where you get the file? In the project folder. By default, it will go into the project folder. Sorry, it won't go into the project folder. You have to select the project folder. So I have created the project into the prototyping with FPGA adder. So here is my project, and here is the BGN file. You can see. This is a bit file. Somebody asked me, can we see the bit file? So this is a bit file. Is it visible, madam? Please tell me. It is shown with the name bit file, okay, .bitstream. So right now it is showing Papilio loader bitstream because my default loader is a Papilio loader. Click on this and open. That's it. And program. If you want, I can repeat the process. See now. Once it is done, we can check. Is it done? Yeah. It is not working right now. Just a minute, something has happened. Or I have chosen the wrong file. Or these are the pins which it's using. It should open actually. Just a minute. Did I do something wrong into the file? A in, B in, C in, 68, 69, 70. That is correct. Sum carry is 46, 47. Let me check. DP switches 68, 69, 70 and 46, 47. Okay, this is correct. So what is the path I have taken? Adder that UCF generate programming file. It is correct. So what's getting wrong? Is it not working? Okay, wait a minute. Okay, now my port is changed. Program. Did I selected the wrong one? Both. Okay, till then finish that part. I'm checking whether I have made any mistake in selecting the part because everything is right. Okay. Okay, I will do one thing. I will redo the synthesis. Probably there are some problem with the synthesis. Otherwise, there is nothing I have changed. Okay, if you want to remove the previous thing, you can do project, clean up project files here. Okay, and then generate programming file. That's it. So everybody finished with the coding? Till then, you may finish the writing of the adder UCF file. I have provided all the files as it is. Okay, now you can see. Is it visible? The previous synthesis was wrong. Will you please tell me, is it visible? दिख रहा है सबको?
Yes, sir. Yes, sir. Yes, sir.
Yeah. Now I can change the values. See this? कौन से पिन से देखते हैं? ये वाले पिन से, लेफ्ट वाले. You can see this. See this. All 0. Then 1. Then 2 1 है तो carry 1 हो जाएगा. See this? दूसरे 2 1 है तो भी carry 1 हो जाएगा. And तीनों 1 है तो both 1 हो जाएंगे. You can see this. Is it visible to everyone? The 3 pin, these 3 pins are the pins which I am looking for. These 3. These 3. Okay. You can see the 6, 7, 8 pin. Okay. These pins. Okay. So board पे numbers different होते हैं थोड़े से. So these are the pins which we are looking for. Okay, up to this point everything is clear. Are you all able to understand what I have done? From where you can download the downloader that I can tell you. Here you can find out the downloader for Albert V2 if you are using Albert V2 board. Or there are multiple downloaders available which you can use. Here, this is a downloader for this is configuration tool. You have to download this tool. I'm putting this into the chat box. Okay. From here you can download configuration tool. Please use this configuration tool. If you click on this, it will download. It is a very small tool, 6.7 MB tool, 6.7 MB tool. So if you are using the this Pneumato platform, then you need it. You will need it. Okay. Okay, किसी का हो गया यहाँ तक? Has anybody performed this synthesis or simulation like this? If anybody is having the board, at least आपका bit file generation हो गया? Will you be able to do the bit file generation? So in the project, you have to follow this procedure. All students has to follow this procedure. First, do the programming, do the functional simulation, synthesis, then put it onto the board using UCF. That's it. So nothing else they have to do. Most of the procedure is automated. So the biggest part is to write a program. Okay. So,
Sir,
yeah.
sir, am I audible?
Yes, yes.
Sir, actually, I was facing the problem in the test bench to get the waveform from the test bench.
Okay. What
Actually,
was the
I
problem?
tried the test bench for the half adder initially, but that waveform window was coming. But how to change the bits over there? That I got stuck.
Madam, why do you want to change the bit if you have written the test bench? Have you not written the test bench?
The test bench I have written, but it was only completely red line. It was coming, and it was
Red
showing
line
AB.
means, madam, it means you have simulated the lower module. You have to click on the test bench before simulating the module.
Before simulating the module, I have
See,
to.
you have mistakenly simulated the adder.v file. You have to simulate full adder_tb.file.
Okay.
You have mistakenly simulated the lower module. That's why you are able to see the red lines. If you have written the test bench, the top module will simulate.
Okay.
Click on the
Sir,
module and try
Okay.
once.
Okay, I'll try. If any doubt, I'll share the screenshot with you.
Yeah.
Okay.
Surely, madam. Okay. So now the next part is watching timing diagrams. So here what you can do is, after place and route, you will be able to see multiple things which are very useful for your project. See this. You can see analyze power distribution, analyze timing floor planning, generate post simulation route model. Here you can create one more model and you can check how much that model take times and whether it is matching. If this module simulation and your functional simulation is matching, that means it will work on the board also. Okay. Generate post plate route simulation model. So create this model. Analyze post route simulation. So this will be your timing report. You can see this. Uttara madam, will you able to see this? This is the pad to pad.
Yes, sir.
This is the
Yes,
pad to pad.
yes, sir. Pad to pad. Okay, sir.
A into carry, then B into sum, C into carry and sum. So the highest delay will be 8.7.
Okay.
So in fact, we can generate a power also.
Yes.
How much power it creates. So tool has all the capabilities, only everyone has to explore the things. It will show everything. See this. It shows all the things. Effective TGA, maximum ambient junction temperature. Then it also shows, see this, on-chip power, logical power, signals, and total power is 0.011. Here you can see the estimated, this is estimated, this is default temperature, and calculated. These are the calculated results. So look at this, current, supply power. So this is quiescent, dynamic, and total. So everything is available with this tool. Only one has to check each and everything, and it will work. I hope this is up till now everyone has done. So we'll go for one more program. So shall we go to the 7-segment display? Shall I go to the 7-segment display? Shall I start? Or is there any problem right now in the full adder?
Sir, I'm at my end. I think some procedure is different.
Okay.
Just taking me to boundary scan. And then I think
Madam, probably you are using the impact.
Okay, sir.
Madam, what happens is when you are downloading onto the board, you need their own downloader. So right now, whatever I am showing is for the Pneumato.
Okay,
For
sir.
your board, you need a different downloader. Or it might be possible that impact will work if your board is from Xilinx.
Yeah.
Have you got the board from Xilinx?
Actually, it is from some other vendor, sir.
Okay, see, basically you are probably targeting this, right? Configure target device. Are you doing this?
Configure target device, yes.
Yeah, if you do this, the impact will open and then you have to do the boundary scanning and everything.
Yes, that all things are happening.
So the better solution is whatever the downloader I have shown, take that downloader directly. It might work with your device also.
Okay, sir.
It is just a configuration tool. If that works, then fine. If doesn't work, then what we can do?
Okay, so that means I have to skip the other steps and directly have to use a downloader.
Yeah. Only generating file is required. This will be required if your board is compatible with the Xilinx.
Okay, sir.
Okay.
I'll try that.
Yeah. Anyways, if you are going up to the generate programming file, that means you already understood the procedure. The remaining part is just downloading.
I have the bit file generated. I just want to download it now.
Yeah, that will happen. That's not a big problem.
Sir, one small doubt. In my case, the installation just got over because it was giving many errors. So when finally the selection, I'm supposed to select this. So the tool, get my purchase license, I cannot do because it's not the purchased one.
Yeah, Webpack.
So Webpack only, no? Okay.
Webpack. Webpack license, it will download by default and it will work.
Okay. Thank you, sir.
So I guess most of you are today having few problems related to the setup. 1 week you are having. During that time, solve these problems. I will not go for much more details today. I will only show the 7-segment display. So in 1 week, you will be able to do all these kind of things. Okay, so now I will go to the next part. That is a 7-segment display. Okay, now what I have to do is, I have to create a new file. So now instead of creating a new file, what I will do is, I will add the file. I will show you how to do the adding of the file. And already I have shown you how to create a new source and write a file. Now I will tell you if you are already having a code, how to do it. So I'm already having a code. So I will add that file. So go here. So what you have to do is, in the same FPGA project, I'm adding a new file. Okay. So if you are having a multiple files in the system, how to handle that also I will show you. Okay. Go here and click on add source. Instead of a new source, you may click on add source. After add source, what you have to do is go to the location of the file. So I have created one file already yesterday. So I will select that file. See this. I will show the code to everyone what I have written in the code. So decoder 7-segment display and UCF file for it. Okay. Okay. So now remove. Yeah. Okay, now look at this. Decoder 7-segment display. What I have done here, decoder 7-segment. I have created a simple decoder. input is 3:0 SEL, output 2:0 anode out. Why anode out? Because see this 7-segment display will be having, I will show the hardware, then you will come to know what I am telling about. Then we will stop for today. Okay. Is it visible? The board?
Yes, sir.
Board visible? Okay. Now look at this. These are the 7-segment displays. On this 7-segment display, the thing is that it will be having 3 anodes. Okay. And all these anodes are connected to a single wire. So all these anodes are operated by the single wire. But there will be 3 pins for the anode. So that's why I am taking 2 down to 0 anode out. So that means 1 pin for one 7-segment display. So this will be having 1 anode, this will be having 1 anode, and this will be having 1 anode. So that's why in my output, there will be output 2:0 anode out. Okay.
Sir, can you just pin that because students are not able to see what you're showing on the board?
Okay. So
Pin
what
that.
should I? Huh?
The video one. Can you pin that? So that will be.
I understand. Understood that. I will ping that. Just a minute. Wait a minute. Is anybody able to spin that? Because I am onto the mobile and I am not able to do it due to some reason. Okay, हो गया pin हो गया.
I think, sir, you have to do it from your screen only.
Yeah, here I'm not able to do it because. Okay, just a minute. I will do something from my laptop. Better way. I'll be able to pin that from my laptop. Wait a minute. Yeah. Is it there now, madam? I think now I am pinned.
Yes, sir.
Okay. Now see this. There are 3 anodes. Okay. For 3 7-segment displays. So I cannot write it as an input in the program. I have to write it as output. So that means from the program, 3 anode signals will be sent, which will start the this 7-segment display. And for this 7-segment display, you are knowing the pattern A, B, C, D, E, F, G, H. So that type of pattern will be there, and accordingly the code is written. I will show you the pattern. First, I have shown the board only. Okay. Now I will show you the pattern, what exactly the pattern is. Just a minute. Okay. I will go back to the presentation. Okay. So will you be able to see this? The screen? Yes, yeah. Okay. I will show this onto the Jamboard better way. So everyone will understand. So the pattern is something like this for the 7-segment display. Okay. This is, so it will be something like this. A, B, C, D, E, F, G, and this is H. H is nothing but dot. Okay, this dot. This dot will be H. So the pattern will be something like this: A, B, C, D, E, F, G. So if I wanted to make something onto this display, I have to mark it as 0. So if I mark 0 here, so that means this line will be on. So if I wanted to make 3, I have to make this 0, and this 0. So this will be 3. Okay. In that way, I have to write a code. So I have written the code in the same way. So this is simple. Assign anode out. All the anodes are made 0. That means all the anodes are on. Always select. So select line is the select line. This SEL 3 down to 0. Then for 0, I have to write something like this: 0, 0, 0, 0, 1. Only एक pin को 1 किया है. Okay. If you see this, only this pin is 1. What does it mean? So this is 0 and all other are 1. So all will lighten up. This will not lighten up. So what happens? This will be 0. If I make 1, what happens? 1 will be, this will be 0, this will be 0, and this will be 0. 3 pins will be 0. Say this. 1, 0, 0. So for 1, these 2, 0, and this is 0. So which are these pins? You can see. A, B. This is B, C, and D pin. So this. Sorry, A, B, C, D, E, F, G, H. So something like this. So A, B, C, and one more pin. This G pin. Sorry, G pin is made 1. So 1, 2, 3, 4, 5, 6, 9, 8. So 7, 8, 9. So all the things are calculated like this. That's it. This is 7-segment display, and we need one UCF file. So let's add the UCF file for this. So I will add the UCF file. I will show you where is the UCF file for this. I have created a UCF file also for this. Okay, because yeah, there is problem. I have to make this as a top module. So now this is a top module. You can see this. Now the UCF will go below this. I will remove the adder.ucf file. So for decoder, this is the UCF file. You may see this. 7 segment 7. This is pin number 17, 117, 116, 115. So 114 to 117, I have connected like this. SEL 012, 68, 69, 70. Okay. So these are the inputs which I am putting. And enable sare ke sare 0 hai. So nothing I am forcing from the tool. Only I am forcing from the tool is the select line. So let's synthesize this module. See, if you have multiple modules in the system, you have to make one of the module as set as a top module. Okay, so I wanted to make decoder to synthesize, so I am making it set as a top module here. Now it is a top module, so it is not showing. So you have to set it as a top module. Now it is a top module. Okay. Then generate programming file. That's it. Again, then I will show you the result. And that's it. So is there any question till it gets synthesized? I will answer the question if any. If you have any question, please ask. Till then, I will answer the question. After synthesis, I will show the synthesis and then we'll finish today's session. Enough for today, I hope. All also require time for installing the Xilinx because many are getting errors. They have to solve those errors. Then there will not be any problem in next session. In the next session, we'll go for the bigger designs. Okay, is there any question? If any question is there, please tell me. It is already on the YouTube. And it will remain onto the YouTube. Anaga madam, YouTube पे session fully available है. ये निकलेगा नहीं अभी, वहीं रहेगा. So that is what I am saying. If you are not able to do today, you will be able to do this in a week. And assignments also floated in that way only. Okay. Now synthesis is done. Generate file is also done. Let's download the file onto the FPGA. So I will select the file. Decoder 7 segment prototyping with FPGA. So I'm selecting this file. Open. Program. Now you can see the output. Onto the board, I will pin the result so everyone can see this. Okay, will you be able to see 777? Okay. दिख रहा है सबको?
Yes, sir. Yes.
Okay, I will change now. Now this is 6. See this. Now I will make it 0. You can see this. 0. Okay. Now see this. 2. Here I am making the change. You can see the pin 0, 1, 0. If I make the pin see this 0, 1, 1, 3. You can see the pin. The last 3 pins 0, 1, 1. You have to see these pins. These pins 0, 1, 1. Okay, you can see here 3. Now the question is, why all the 7 segment displays are showing 3, 1, 2? We should show only 1, right? Why 3 are showing 1? Has anybody got this problem? ये problem समझ में आया क्यों है? Has anybody got the answer for this? Please try to understand, on the boards, all these anodes are tied to only one pin. So what happens is, when you put anything, all will on, all will be off on the same time. So now if you wanted to use all the 3 for the different purposes, the only solution available is that you have to multiplex this. And once you multiplex this, the thing will work. Okay? Is it done? Is it clear? So how to do a multiplexing, that we will see next time. It's a long program that we'll see next time. So I hope we will stop today. Oh, enough for today, I guess so. काफी हो गया है. Is that okay? Shall we stop today?
Oh. Yes, sir.
I think आज के लिए काफी है.
Yes, sir.
Yes, sir. Thank you, sir.
Yes, sir. Thank you.
Yes, sir. Thank you, sir.
Yes, sir. Thank you, sir.
Okay. If anybody is having any question, please ask. I will answer those questions for next 5-10 minutes. Then we'll stop. एक बार सब लोग वीडियो ऑन करेंगे. Will you please switch on the videos? I can take one photograph. Just a minute. So all these sessions are available on the YouTube. You may directly try those sessions. And throughout the week, you may try all these sessions. So there will not be any problem. Just a minute, I'm taking a photograph. Actually, many people are there, so it is taking little more time. Okay. Thank you. Problem. You put it onto the website, or you may put into the chat box or in the YouTube stream. I will answer all those questions. And the next lecture will be on 27. On that day, we will handle the project, actually, wall history. Okay. So if there is no question, we'll finish the session.
Sir.
Yeah.
Sir, yes,
Yes,
I
madam.
asked you that about the boundary scan and all. I could complete that process and it is showing me succeed message. But then when I'm connecting on the board, I'm checking, nothing is happening. What could be probably the problem? Because when I'm
Madam,
changing
impact
the
start
switches,
karna padega. Have you started the impact?
Yeah, it is starting, sir, and it is showing me I could program it, and it is showing me success message.
The reason could be two, madam. One reason will be that the pin diagram is not matching. But if the pin diagram was not matching, the error should come into the map. That is not happened. So probably the reason will be somewhere there is problem in the FPGA flow, which you have implemented. You are just saw my design was also not working. So once run it one more time. If that is happening again, then we'll talk about it.
Okay,
then
sir.
I will see what is exactly happening. Because with impact, the things are completely different.
Acha, sir. Okay. Yeah. Means initially I was getting error, but now it is showing me that the program is burning here. But when I'm making the switches on and off, nothing I can see on the LEDs.
Yeah, that could be the problem that UCF is not taken at all.
Okay.
So ये हो सकता है कभी-कभी UCF लेता ही नहीं है वो because during the flow we sometimes change the code and that is got accepted and UCF is not created. That should be the reason.
Okay. Means I'll just shut down once again everything and I'll try.
Yeah, don't shut down project. Go to the project and clean up project files.
Okay.
Here you can see. Go to the project and clean up project files.
Clean up project file. Okay.
That's it. So it is like clean all in the C programming. हम करते हैं no clean all. So all the files will be eliminated.
Okay.
Only VHDL, Verilog files, the HDL file will remain. Everything will be eliminated other than UCF and Verilog files.
Yeah. I did that. Fine. I'll try, sir. Thank you.
Yeah. Is there any other question? Ayush, you can stop the streaming now.
Sir, this video, today's recording will be available on YouTube, no?
Yes, madam, that is available there all the time. One more, and this recording also, I will edit and upload onto channel. So it will be also made available. The important part will only remain there. So it will be little bit smaller video compared to the other video.
Okay.
I will edit it and upload it.
Okay, so upload on channel means that website.
Yeah, that is our department's channel.
Okay, sir.
That website is a link only.
Okay.
There you can find all the videos for our. So on that channel you will find all the videos of this program.
Okay, sir. So actually, I wanted to ask one thing. We have Spartan 3E board, and on that there is no 7-segment display. There is only LCD. Means LCD is there, switches are there, and I think LEDs are there.
ADM boards,
It was given by actually Xilinx only. It is, I think, 6 to 7 years old.
या Xilinx से लिया है या वो आई थिंक अपने एडीएम से लिया होगा डायरेक्टली
Xilinx से ही लिया था क्योंकि आई थिंक मतलब हम लोग के कॉलेज में वो खरीदा था Xilinx का जो पैक है वो.
ओके सो मैडम एलसीडी के लिए आपको कोड करना पड़ेगा या तो बाहर से 7 सेगमेंट डिस्प्ले जो ब्रेडबोर्ड है उस पे लगाइए और वायर कनेक्ट कीजिए.
Okay. So means from board we have to take wires for the 7-segment display.
Yes. So दो headers होते हैं ना जो साइड में मैंने दिखाए थे अभी headers. So ये headers. If your board is having headers, please check this. Will you be able to see this? These headers. Yeah.
So I think yes, sir.
If such headers are there, then take wires from those headers. Input output जो wires है उसको लो और उसको यूज करो. दूसरा कोई solution नहीं है. ये old boards है तो ये old boards के साथ ये बहुत सारे ऐसे issues है. Mostly these boards come up with some daughter boards or the small boards which are which will be with the solution, complete solution. So on those boards they give these kind of 7-segment displays and everything. So comparatively these boards are quite cheaper and better than those boards. Those boards your college must have bought with lot of money because we also bought such kind of boards, but now those boards are not very useful. At least nowadays.
So which will be the better board means cost wise also we should buy if
Numato. That's why
Numato which one?
Albert V2. This is, but madam, these boards are very small. This will cost you 4,500. There is one more board with the Vivado Mimas. There is one more board Mimas that is 5,400.
Okay, Mimas is 5,400 and this one is 4,000, no?
4,500. Albert V2.
Albert V2.
And there is one more board from Gadget Factory, Papilio boards. Those will be around 4,500 to 6,200. It contains Arduino core also on the board.
Okay. So for students to do the project, that Albert V2 is enough, no?
Madam, Albert V2, Mimas and Papilio Pro. All these boards are good for students. Very low cost boards. So according to your college, you may choose. I suggest Albert V2 because these are very cheap and most of the college are ready to buy those boards.
Okay. So to buy this board, we should contact the vendor, no? Numato Lab.
Yes,
we have to
Numato Lab. I will share the quotation and number.
Okay, sir. Please share that so that we can buy it. Okay, sir.
Yeah.
Thank you, sir.
Yes. Is there any other question? Okay, then we'll finish today's session. Thank you very much for joining the session.
Thank you, sir. Thank you.
Thank you, sir.
Thanks a lot, sir.
Thank you, sir. Thank you, sir. Thanks a lot.
Ayush, you may leave now. You might be having some other things to do right now. Yes. Yeah. Okay. Thank you. Thanks a lot.
Sir, you were talking about those